Welcome back, everyone. How are you doing? So another surprise stream, another C# stream. 2 days ago on Tuesday, I was working out of frustration, moving this kind of calendar planner from the Nim language to C#, and I just finished to the point where I had it working, and I actually revamped the whole approach. It's a little bit faster now. It actually completes the things I want to complete. And yeah, now it'll be time to kind of optimize it. And I figured out, you know what? I might record it. It might be useful for somebody. So let's get straight to the point. So just quickly introducing what the problem is and, overall what the project is doing. This here is like a general overview of what's going on. Let me just make it a little bit larger for everyone to see. Okay. So the whole idea is that we have a list of agents. Let's call them people. Okay. And this is not one-to-one with this here, but the idea is that we have a list of agents and a list of weeks to kind of assign them to. And week 0 is like the previous week of the previous period that we generated. And this way, we can say the previous week who was assigned. We can see that David, George, and Harry, they were assigned. And those X's mean that these weeks for particular people are basically off limits, and they're not available those days. So the way I made it so far is that we basically create a new planner builder. We tell it there's 5 weeks that we need to plan for. There needs to be at least 2 agents per week. That's the very important requirement. There are 2 agents needs to be basically added per week. 2 weeks assigned to each agent. And each week needs to have assigned at least 2 agents. Okay? And then we add agents, give them a name just for display purposes, and excluded weeks, which is basically a list of weeks that they are not available on. So Anne, for example, is excluded on week 1 and 3, therefore it can be assigned for that place. And at the end, we're setting that additional, the previous week, the week 0, the one that we're not planning for because it already happened, let's say. One important rule here just to mention is that each of those agents, when having the weeks assigned, the goal is that they don't have weeks assigned back to back. So for example, here, week 1 and 2 will be bad because Bob would be basically, 2 weeks in a row assigned. That's bad. And if that happens, it's a conflict. So let's say we have a situation like here with Harry, where he can be on week 3, 4, and 5. So we would need to say he can be a week 3, 4, and 5. And he was also assigned on the last week. So anything that will go here would already be in conflict with the previous week. And the only option is here. So basically this guy will always have a conflict. And that's all it means. So after we have that, we basically call something check has unavoidable conflicts. This was basically a little check that will let me know that if there's an agent like Harry in this case, that basically it's impossible to avoid conflict in his case. Okay. And then we basically, what we're doing is I have some setup done where we're basically measuring how long the iteration takes on average. So we have some measurement time. We keep track of how many iterations and basically a loop until it finishes, where, we have a stopwatch. Then we call the planner, find plans loop iteration. So this is iteration to go through a next plan and maybe, find possibilities. And at the end, we just, log it and show it and show some stats, okay? So the way this whole planner works, because if I will go into the code, there's a bunch here. I won't spend too much time on explaining it right now because we'll be going through it. But in a gist, what it does is that, it calculates the initial state for everyone. That's actually during, planning, during the planner. And what we're doing is basically, now we're going to focus on this particular agent. We're going to generate all the possible combinations of 2 days in this case, having selected for the agent. We also mark which combinations result in a conflict. We have them there just in case. And then we basically create all the variants of the plan that has that specific combination. So in this case, one combination will be week 2 and 4. Other combination will be week 2 and 5. And the last combination available will be week 4 and 5, which would be marked as a conflict. So we have those 3 possible things to happen. And we basically create 3 plans, each copy of a plan with those 3 days selected. And then iterations go to the next agent and basically generate plans for all the variants of possibilities that could happen for this guy. And it goes to the right, to the right, to the right, to the right, and just generates all the possible plans. And as it gets to the end, it basically checks if this plan is valid or not, blah, blah, blah. And in case of, it also tries to do some optimizations that if there was already one valid plan, valid as in one that doesn't contain a single conflict anywhere, it's just gonna start skipping everything that would have conflict. So, the variant here with the conflict here will be instantly skipped and therefore will go faster. But because we have a conflict here that's unavoidable, it will just keep going through all the possibilities of, worst conflicts and everything. It will just, do everything. So this is our test case that, worst case scenario. So our scenario for testing is we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 agents, 5 weeks. In the standard 2 weeks per agent and 2 weeks per and 2 agents per week, so let me run it. Let's see what it looks like when we run it, because we'll have a little bit different numbers than in a thumbnail, because right now I have a little bit more running on a stream. Okay, so wow, we're going way slower over it. 30 million iterations already. We need to go to 360. Wow, this is gonna take a while. But hey, I have a screen capture going. I have music playing. I have a little server for the messages running. So yeah, let's try it. I'm gonna write a message on Twitch. Hello, Twitch audience. It should show up on my screen, I hope. Yes, it showed up. Cool. So yeah, you can see the chat from Twitch, but I can also do hello YouTube audience. Okay, and it should show up as well. Please show up, please show up, please show up. Doesn't show up. I know why. Gonna fix that in a second. Should. Wrong buttons. Scroll out a little bit, but we should be fine. So in the meantime, while this is running, you can see that this is already using up like 28 gigabytes of RAM, which is, 30 gigabytes of RAM. It's chewing through it quite a lot. But it shouldn't go too much, much higher. Well, the thumbnail had 31 gigabytes, but I guess a different spot generate way more. So we might get to probably 45, 50 gigabytes of usage. Oof. Yeah, in the meantime, I need to fix this guy. Let's take it off screen. Save it, and you'll see a bunch of messages show up. Sorry about that. They will disappear in 2 minutes. Okay, our thing finished after 360 million iterations. So having the same kind of situation, maybe we can make like a quick little spreadsheet or something. Let me open up in a different tab. Am I logged in into Google here? That's a good question. I am. Awesome. Whatever those things are. And let's go new sheets. There we go. We're in new sheets. And we can zoom in a bit. So what we can extract out of here, let's see. So let's do name. I like, run name. We'll call it baseline. Okay. And what we're gonna do here is we have iterations will be 360327814. Okay. Then we have time will be total time 159,049.84. So that will be milliseconds, right? Okay. Then we have average time. Will be we can calculate, right? Yeah, average time. Milliseconds. It will be this divided by this. Okay, we'll just have it here. I will just display it times million. Okay. Whoa, divide by 0. What the hell? Be 2, please. Okay, and this will be nanoseconds at that point. And do we have anything else? Deviation, whatnot? Weird. Percent, whatever. Yeah, things are calculated relatively okay. So, one more thing is that this IDE automatically basically notices that there are some problems. So if I'll go to dynamic program analysis, okay, it already tells me that in few areas we have some problems, okay? So in this case, wow, this is like really large. So in this case, we have this frozen stand append state basically takes up that much RAM, okay, allocated size. Max observation at some point was a little bit more, but let's focus on this one, okay? So let's copy this and we'll do frozen frozen state dot append. Okay, and we'll just do this, and that will be gigabytes. We'll just keep track of that one. Yeah, append state, whatever. Come on, append state. Let's make those actually wrap. I made it a little bit too large. Where's wrapping? Text wrapping this. There we go. Okay. So we've got this guy. Yeah, we can just use the space. It's gonna look better. Okay. And then we have also array extensions append. That's probably used from within the append state. And that was 23700.1. And these are megabytes, not gigabytes, okay? Because I would like to track how much we can actually reduce some of those areas as we're tackling them. Okay, and then we have planner loop iterations. Some kind of function. Okay. Oh, this is the any? Really? Let's just note it somehow. It's a little bit confusing to find which spot it is. So let's do find plants, and we'll call it func. Okay. And this will be 17872.8, and the last two will be also find plants, but it will be the SZ generic array. Let's just do array enumerator. Okay. And that will be 11341.5. And then we have last one, because these were all whatever small heap objects, but then we have also large heap objects. So we have the find plants frozen state, and that's an array, and that's using 8191.9 megabytes, and that's the large heap storage, whatever. Okay, so we have our baseline recorded. Let's just trim it down a little bit, and we'll be able to start noticing, start recording basically what the hell's going on. Come on. Yeah, this is good enough. Not pretty, but we have it there. So the thing is that before we start tackling those, the first thing I would do is go through through all the types of data that we're storing, and just make them smaller, because everywhere I used integers, and I don't even know if this is using 64-bit integers or what right now. Oh, we shouldn't. So we have things like weeks count. That could be easily a unsigned integer 8, right? What? How? How do I? Really? I need to do u byte, u short? No, not short. Just byte, right? Yeah, let's just do it byte, okay? Okay, because these will be always tiny, okay? So let's update those. I don't think they will have any kind of impact, but let's just resolve the issues related to them, okay? Now we just need to make sure all those 3 are also a byte, and that will cause issues probably in Planner Builder, where we're storing them also as integers, while we need to make them not so. Okay. Okay. Let's try to build it. Okay. Let's see if we have any issues. No issues. Okay. So that part is good. But now we're going to a bit more interesting. Agent names, just a list of names. We need to still have it here. But again, it's not an issue. It's not something we're referring to all the time. This is just sometimes to get a whatever. It shouldn't be an issue. Let's see if we have anything else here that's like straight up using integers or something. I don't think so. We just have a bunch of definitions. Yeah, I don't think there's anything here nor here. Yep, basic math. Cool. Okay, so all this, I think it's gonna be fine, right? So next thing will be actually to go a little bit further. In our planner builder, I don't think we'll have anything else yet. Yeah, not here. We don't really worry about planner builder because this is just running once. So let's see at all the models that I have. I'm just gonna close everything up. I'm just gonna leave the planner open. So what do we have here? We have agent state that we're not using anymore, actually. So I can get rid of that, okay? Because I just had the... Yeah, none of that is needed. Delete. We're gonna clean up a little bit. Agent state combination. That's the one I am using. It's just an array of state combination. So we don't worry about that here. Agent state status, not used anymore. Combination. And combination is just a generic way to represent a combination. So this will be used, and I believe will be used with an integer, right? So that's that. Form plan, we're not using that anymore. Okay. Frozen state, yes, that we are using. Okay, and this is where we can. This is like the big one that we have issues with. So we have basically states, and states is basically a list of numbers, like IDs of which combination was selected for each agent. So this is never going to be larger than 15 or whatever. So we can easily use byte, okay? And for selections per week, that's also is basically how many agents are assigned to a specific week. And I don't think we're gonna go over, something like 15 agents. So, hey, limit of 255 agents. If we have something like that, we'll have a big computer to brute force that number of combinations. So that'll be fine. Therefore, weeks count can be byte as well. And selections per week, and this will need to be byte array. And then that's that. But we have some errors. Yeah, we have those errors here that, hey, during this thing, we allocated so much data because this is repeatedly being called. And this whole append is basically the one that assigns a lot of data. So let's go to states append. And that's our append. Okay. Really? State combination ID. Oh, this needs to be a byte. Now it's happy. And with increment, oh, that's the one. Selections per week. Dot increment. And I believe that was in our array extensions or something. Yes, so this is expecting everything to be integers. Oh, we just changed them to bytes. And this will be byte array. We're cloning a byte array, so yes, there's a lot of stuff involved here. Okay. So that is that. And now this is happy, but our planner ain't happy. Why? What's the problem here? So plans select a combination. Plan is our, oh, okay. So we need to go and edit the plan. Plan itself, pending plan. And the selected combination is integer. Well, we need a byte. Okay, frozen state we have plan. So basically each plan is basically a form of a frozen state, which is basically that list of elements that happen that were pre-selected with, you know, little pre-calculated weeks and whatnot. While selected combination is the one that is already pre-selected to be assigned next. So that's that. So our pending plan is here. Oh, now so many other things won't be happy. So let me just go through state combination to just make sure that I don't have some weird stuff here. This is all good. A weak state. We don't have that either. Delete. Plan status, planner builder, pending plan. Yeah, that'll be all good. Let me just go to planner builder to just make sure that list of excluded agents per week. So that will be bytes, previous week agent IDs, bytes, excluded weeks, bytes. There we go. Everywhere we see an integer, we'll be adding bytes. Agent ID here will be a byte. Okay, we can just force it to be a byte. No big deal. Or we just do it like this, right? Find index. There you go. And therefore, how the hell do you make it a byte? Oh, I see. We cannot have it as a byte because find index, we're using it for that, so we'll throw an exception. If not, we just force it to byte here because we need that negative value there. Okay, so we're good. Planner build, all that happens here. I should be able to just have just a loop, no big deal, no big deal. And agent ID will be byte, okay? I keep those things bytes so that we have things consistent. Next go to week. Can I convert argument the byte to enumerable integer. Contains wait. Week index is integer. See? There we go. Our for loops will need to be bytes from 10 times. So empty weeks are showing up as integer. Look at that. There we go. And byte. Private state combination. That'll be all bytes. Apply combination. Yeah, everywhere I see integers, so just turn them into bytes. What did I just click? Paste. Okay. Where were we? bum, bum, bum. Agent IDs, please be byte, byte, bytes left and right. And conflicting. Ah, see the planner? What? This planner still expects. Oh, there we go. There we go. Bytes. Dum 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 dum. So that's good. We continue. We continue. No integers here. First conflict index. Turn type. And this should be byte. There we go. Because everywhere it assumes to be integers, and that's the problem. We've got that, that's good. All those bytes. And weak, let's force it to be a byte. Okay, good. Looks like that is fine. So planner build is finished. Let's go to planner. So all that is fine. Yeah, we don't need all those inits here. Or do we? Never mind. Not a problem for now. This is all bytes. Bytes. And bytes. But here. First conflict indexes. There we go. We're holding bytes. Okay. Good. So scroll down here. Combination ID. Yes. This will be a byte. Blah, blah, blah. Printing is fine. Agent ID. Let's keep it a byte. Okay. This looks good. And then for loop iterations. This is where fun begins. Okay. Yeah, this is a problematic one. We used a .any, which I guess generates lots of enumerables and a massive number of enumerables because this will be called once per iteration. Well, maybe not once every iteration, but every finished one. Yeah. And we could avoid it probably. But we're gonna get there. Let's just continue with the thing here. Combination ID. Byte, please. Another combination ID. Byte, please. And here, byte, please as well. This is a bunch of copied code just to keep it optimized. As I am not sure if we actually... If in C# you can like force inlining or something. It would be awesome if you could just force inlining because that would save some typing. Okay, that's it, I guess. Let's see if this builds. It actually builds successfully. Look at that. That's easy refactoring. So if that's the case, let's rerun it and see if we have any time difference or performance difference or what. I can bring this up and lead calendar is climbing, but something tells me we'll be using a lot less because a lot of data is being an arrays and therefore it should fill up a bunch of, it should fill up those little, whatever you call them, because I guess stores in chunks of 32 or 64-bit, probably 64-bit long chunks of memory. So we'll be able to fill them up a little bit more, with more data than we did previously. And wow, I'm not sure if we're going fast or slow because we're just at we're at 130 million operations. Okay, we're doing well, and we're only at 14 gigabytes so far. So by that time, were probably at 25, 30 last time. So this might go way better than I expected. If that's the case, that would be awesome because, yeah, huge memory gains. And we still have room to go. Okay, 215, 220 million. Okay, come on. What happened? Little hiccup. Interesting. Okay. We finished. Total time increased drastically, but something tells me that's not that much related, huh? Okay, so let's write it down. To our little spreadsheet. Wherever it went. Okay. So int to byte. We again 360327813. Oh. And no, 14 iterations. Oh, come on. Time will be, for some reason, much higher. Okay. But then we can go to the dynamic problem analysis, and numbers looks like they decreased. Okay. That's exciting. So, for the append state, we have 24112.1. That's, wow, like a lot. 7 gigabytes less. Okay. And 9 to 60.2. Okay. For fine plans, we went down to 17441.9. So just barely. So here with the array extensions append. Oh, wait, what? What the hell just happened? Because things rearranged a little bit. Like this one here is still where it was, right? So I can write that down. and 8191.9. That one stays. Find plans array and array enumerator. That went to 7328. Okay. So that's better. If I do 0.0, it's yeah, remove it, whatever. They have find plans funk. That actually went up to 19 to 60.2. Look at that. While the array extensions append went down to 17,441.9. So we have huge gain here. Well, here's a slight increase. I guess maybe the any operator from link is actually not optimized for bytes, but more optimized for something like integers. That's a possibility. Okay. But nonetheless, that's huge gains. Very huge gains. So let's maybe tackle that anything, okay? That was this guy. There we go. This little thingy. So right now, we're basically going through to the new state selections per week. And we check if there's basically whenever we're finishing, whenever we got to the plan that has all the agents already pre-selected, therefore we finish selecting, we need to check if it's a valid one, right? There are a bunch of checks like, built in from pre-computed data before, but at the end, we're basically checking that extra rule that says that there must be at least 2 agents assigned to each week. So that's what we're checking here. We're just checking if any of them has it less than that, we're just marking the plan as invalid. And this would be for most of the plans, it will be invalid. So, maybe not for most of them, but for a lot of them. Or in this case, for most, because we're already ruling out most of the other ones. Yeah, so yeah, for most of the plans that actually went to the end, it's marked as invalid. So what we could do is basically convert link to code. What do we have here? We'll start for each, okay? For each selection and selection per week, we'll do this if. But we can expand it for each, convert to 4, okay? So let's see. Selection per week, length. So this will be selection per week index, selections per week. So we'll just call it week. Okay. And we'll just make it byte because we know that there won't be more weeks. So that's that. And therefore, we're not allocating anything here. And we just get the selection. And if selection's value is this and that, we do that. But we can just go straight up that way. Okay. And just invert it. If it's larger than or equal, continue. If not, do that. And let's see if this makes any difference. So, because there should be no big allocations now, right? I hope so. So, yeah, let's run and let's see what happens. I know it's not a very exciting wait, but I'm excited for the differences in, memory usage or whatever. Later, I'll be probably able to look at the live stream and see the actual top memory usage that was recorded here. because that's something I am not really capturing properly. I'm not even sure how to set it up. Probably would need to attach some kind of memory profiler or something. I don't know. Gosh, it seems like we're going a little bit faster. Already it's nearly 16 gigabytes of RAM. Our CPU is a little bit higher. Okay. Wow, going up to 18%. Wow. Not a little hiccup. Huh. Yeah, it'll be fun to actually multi-thread this whole thing. So 150 million. We go to 28 gigs, 29 gigabytes of RAM. Come on. Just 20 more million tries. We're going to 41, 42. Oh, less than it was 45 last time. Or at least 45, I think it went higher. Okay, the time improved a little bit. And number of iterations is the same. Let's just make sure that we have correct data. Yeah, iterations is the same. So we'll just do the any to 4. And time this time was 167,679. So that's okay. Still not better than the first time when I was doing weird stuff. And let's look the most interesting part. Dynamic program. Oh, whoa. Okay, things actually disappeared. They're not showing as issues anymore. Interesting. Huh. So let's see what disappeared. Bum, 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 bum. So our append state is still here. 20.077.4. So that actually, what the hell? That actually decreased. And something tells me it decreased because this decreased to basically 0 or whatever. Maybe not 0, but drastically decreased. Append. Arrays extension append, yeah. This one went up to 18,403.9. So it's interesting that it varies that much. Huh. And then we had only the fun plans, frozen state array stays at exactly the same. Okay, those are not showing up anymore. Interesting. Why did it stop being a problem? How to fix these issues? Oh, this just leads me to fix memory issues. It could be interesting. Read. Okay. Yeah, boxing, unboxing, all that stuff. Yeah, let's not worry about that now. but because we're making progress. So yeah, this is our baseline. I mean, our new thing. Let's actually commit the code so that we get a bunch of improvements. So first thing I'm gonna do actually maybe the ones where I remove the code completely. Let's do remove unused code. Then we have array extensions, 2 bytes, frozen state, 2 bytes, 2 bytes. And in our program, we can ignore that part. Planner builder, yeah, all this is just 2 bytes. And in our planner, we just need to make sure that we take out the part where we changed that array. So here, this part. Unstage this part. The rest is fine. So we'll just do int to byte. And this here was link any to for loop. Okay. That was a nice improvement. Okay, code is up there. I'll maybe share a link on a Twitch chat because YouTube has the link in the description. Bum, 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 bum. I moved the icon, so now I can't find the browser. So let's go to github.com. And this would be lead calendar, okay? That's the little thingy here. I know it has no description. It's just a little plaything for the stream. So here's Twitch. I'll post it on YouTube as well, just in case somebody wants to grab it. So there it is. Okay. So continuing. What else can we improve here? So here, append state. Let's see. We have it here, of course, our find plans loop iteration. And then there we have the new state, where we generate a new state and we basically create a new, create a new, basically new array. So what happens here is allocated type frozen state. Yeah, that's the whole thing. We're copying like a new version of it. So content actions. Okay, yeah. And this will just bring us here, and that's it. Okay. We don't have any other options. The expression body. Oh. Huh. That's an interesting one. Cool. I like that syntax. And this whole append. That's another one that... So let's look at the append. Because it takes states. And in that case, that's a list of, an array of bytes. And what is supposed to happen here is that we define a new array. Oh, this is probably where allocation happens, right? And then we copy the old one to the new one. And then we just add a new item at the end of the array. Yeah. So basically, make the array longer by one element. And we also make like a full copy of it. And that's kind of the idea of this whole append, So yeah, this is gonna use some memory. I wonder if I wonder if it will be possible to basically use some kind of array buffer or whatever we'll call it. Because, I recall there's a concept of something like that where you can have array pool or something like that. Basically, pool of arrays and you can keep reusing them. So, but then we would need to know when we're freeing them. And that is a little bit more difficult, at least in the case of the frozen state, because this is something that's being shared around, that's a record. So maybe we could kind of make it disposable. No, not disposable. Something just add a destructor or something. Hmm. Yeah, because the frozen state will be shared between various plans as it goes. And that's the particular reason why this is a record, not a struct. So let's look it up. Let's look it up with ChatGPT, what it can tell us. Because ChatGPT seems to be pretty decent with C sharp. Go away. So let's think. How could we do it? How could we describe our problems? Our problem. I have a C sharp record type. Okay. I need to run some cleanup code when the object is garbage collected. How can I do that? Here's my current code. Okay, so it has some context that it's what kind of record that is, and it knows the record should be like class. So let's just see what happens if we can do that cleanup, because I recall there's a concept of array pool where you can borrow or whatever lend an array, but then you need to call like give back or whatever to release it manually. Oh, whoa, this is adding a lot. What the hell? So, disposable, seriously? Do not have destructors. Ooh, however, you can implement it disposable interface to run cleanup code when object is no longer needed. While the garbage collector calls the finalizer the destructor of an object, you can't directly control when it happens, but it allows you to manage resources more predictably. Yeah, but I don't want to call it manually. Can I use the disposable without disposing of it manually? I can't control the lifetime of this object in a manner that allows for using okay, let's see if that's possible. I'm not sure. Can control the lifetime of your object manually and therefore cannot ensure disposal code. Relying solely on finalizer is not ideal. However, you can put a finalizer to ensure how to modify your record to include finalizer cleanup. So let's see if we can do this whole finalizer thing, okay? So there's a destructor that calls cleanup, right? And we just have an example. Let's try that, okay? Let's try to add it and see what happens. Because a second ago said that Records don't have destructors, you know? Clean up code executed, okay? So let's see what happens if we're gonna just run it, okay? Let's run it and see the carnage. Oh wow, cleanup code executed. Awesome, we can just stop. Okay, this will be good, right? So that means... Because this whole append, right? It creates new array or whatever. So please explain usage of array pools. Okay. As a class in .NET, it provides a shared pool of arrays which can be reused to reduce the overhead of frequently allocating and deallocating arrays. It is part of the system buffers namespace and designed to improve performance and reduce memory pressure by reusing arrays. Perfect. Reduce garbage collection, improve performance. Okay, and memory efficiency. Yeah. So the idea is that we're renting an array, we're using it, and then returning the array. Okay. So let's see what it looks like. Array pool and shared. Okay, and we just rent, and we need to specify the size of data. Okay, makes sense. And then we just use it. Okay. Process the array. So let's see if this is gonna decrease our speed or not. Append is used only somewhere there. Okay. Clear array. Huh. Interesting. Clear array parameter clears the array before returning it to avoid keeping references to objects unnecessarily, which can help prevent memory leaks. Okay, that will mean that will be in a case if we were actually holding references, but well, that won't be holding references, right? Okay, I see. And then we could have custom pool, right? Max array length, max arrays per bucket. Oh, so this is where probably even more optimization could come in handy, right? When we create our own pool. Okay. And then we can process it, rent it, and whatnot. So append is here while in frozen state we're using that. So I wonder if we could just make like an max arrays per bucket. What the hell is max array per bucket? What is max arrays per bucket? Specifies the maximum number of arrays that can be stored in each bucket of the pool. So an array pool organizes arrays into different buckets based on their lengths. Each bucket holds arrays of specific size. This helps in quickly finding an array of the required. Okay, I see. Oh, so it just makes those buckets and that's that, and therefore the max array length is just an overall thingy. Okay, the maximum length of arrays that the pool can handle. Okay. I don't think we have to worry about that. So we could use the shared one, right? Just to simplify it. So that's that. So we have it here, but what happens if... Because arrays are passed by reference. Yeah, so we should be fine, right? So I could make it that, let's see if this works or not. Instead of doing that, we're gonna do var new array is array pool, okay, of type T in this case. Shared, rent, and we just do that, right? We'll get rid of this one. And we just go on as we did so far. And the only thing is that in the frozen state, we basically need to do the cleanup, and instead of calling it as a separate method, let's just have it here so that it's nice and performant. I don't know if that matters. The states, we need to clean up states. So we'll do array pool, byte, shared, return, states. Okay. Okay, cool. And then an increment. What are we doing in increment? We're not defining a different array, right? We are. Oh yeah, because we're basically cloning another array. Huh. So let's do it a different way. Let's do var new array is the array pool of byte. Okay, rand array. And here we're just gonna do array dot copy. Copy was from an array to the new array and everything. Okay. Let's see if that makes any difference. And of course we need to free it here. Okay. Perfect. Let's see what happens when we run it, if we're gonna get like crashes or something. Another exception, index out of range exception. Index was outside of bounds of the array. Oops. What? Line 130. What did we just do? Did I screw up length or something? Let's look at git and see what we changed. Array extensions. Can I make it larger? No, I can't make it larger than that. Sorry. Array length +1. Array length +1. So that's fine. Well, down here we have array clone, so it'll be array to length. Okay. Program doesn't change. What the heck? What is the problem now? I don't think it's that syntax here. Just in case, this goes back to sure, it was like this. I don't think that should make any difference, but who the hell knows? Let's run it. Same issue, okay? I mean, it went through checks, okay? Unavailable conflicts detected and out of range exception. Let's try debug. Index was outside of bounds. We'll get the new state. Okay. So agent ID is what? 16? Where did that come from? What the heck? Frozen.states length. Holy macaroni, it's 16. Why is that? Okay, we're getting weird stuff here. Why are we getting a length of 16? What? Um, append is the previous array length plus 1. How the hell do we get a longer array? I'm getting confused by now, right now. So let's say that we're gonna bring that copy thing to the way it was before, okay? Um, hmm, very strange. So this one we're gonna keep as new one, but this one we're just gonna copy the, I think the copy I need to go to this side by side or something. Yeah, let's just keep the previous clone approach. We'll just have that. Yeah, we're getting the same thing. Agent ID 16. What? Advanced state of the plan. Plan, frozen state, state's length. This plan should be have length of 0 right now. Just wait a moment, I'm getting confused because let's look at it here. When we created here with the planner, right? We're going here and we basically keep adding the plans. We generate 3 plans. So new frozen state weeks count because it expects the count of weeks. All that, and the new plan just gets added. And whenever we just create a new frozen plan, selections per week is new. Oh wait, we're also creating new thing here without specifying without using the array thingy. Look at that. So, and we're not doing that for this yet either. Okay, here. We're trying to release it, but what the hell? Right pull, byte. And we basically want to do shared, rent, shared, rent. And we're specifying, oh, look at that, it's minimum length. Seriously? Retrieves a buffer that is at least the requested length. That sucks. I need exact length. Really? We don't have one that has the specific length? The rent data size returns a buffer of with a minimum length. I need buffers with a specific length instead. Huh. That sucked. The actual length of it might be larger. Erase, you can still use pull, but you need to handle the fact. I don't want to handle the fact. I'm relying on the fact. This way I don't have to keep things. Rent array. Use the array. Yeah. Yep. Try and yeah, I need to keep track of the data size. Oh, no, thank you. The idea there was that this array was growing by being copied. Hmm. Do I need to implement my own array pool? I could do that. No problem. What's the implementation of rent? Can I... Oh, this is an abstract. Oh. Huh. What are the usages of it? How is it implemented? Okay. Can increase thread safe, might be used by multiple threads concurrently, all that good stuff. So it has a shared array pool. And that's a different class. It's 27 buckets, number of buckets, array sizes in the pool. One of each array length starting from length is 16. Ouch. And that implements the array pool. Okay. Huh. Local, all that stuff. I have rent. Okay, log this stuff. Buffer. Select. Okay. Yeah, looks like I'll need to roll my own. Local array, blah, blah. A little more involving than more involved than I would like to. Let's search online if we have if somebody searched for something like that before. So let's do C# array pool with specific lengths. Exact size array. Haha. 7 months ago. Look at that. That's not bad. Uh-huh. Sizes. I'm fine with unsafe code because I still dispose them correctly. Okay. This fancy helper. Array pool helper. This method will return disposable objects with the desired size buffer. Works with any pool which supports desired size. Oh, okay. Rent array, rent exact. Size. Okay. Rented, pool, rent. Original size, unsafe change, length. Okay. Okay. This is interesting code. Unsafe change length. Okay, so basically the new length, unsaved rented, unsaved as this and that. Okay, so basically force changes it. has the dispose, but it's not disposable, right? Let's, yeah. Oh, using, ay. Social errors and parallel invocations, so no, it's not wise to change length. Yep. Oof. So this is not an answer. Hmm. Automatic garbage collection simplifies program development by implementing to reduce allocations, allocator versus pool. It just explains how it's gonna work, right? So let me think. Sure, we're reusing those, but at the same time, if we look at our logs, we probably won't have them anymore, right? From the run, previous ones. Yeah. But from the time when it worked, we're often holding like something like, 3 million instances of something. So, yeah, I don't like that. Hmm. I wonder if we can just make like a real simplistic version of it. Let's try it. Do it. Array helpers. I mean, we'll just do maybe something like exact array pool. Okay. Gonna call it like that. And even better, we're gonna make it static. Yeah, we're gonna make it static for now, because why not? Of type T. Okay. And what the hell we're gonna do? So the idea is that we could create, I like the idea of buckets. So we can just create several of them at a time and for a specific size. So let's say that if we had a specific size, we would have some kind of bucket, could be basically a list of arrays, right? It'll be a list of arrays. So that will be the bucket. And that'll be like, size of 5, right? So there should be a list of those buckets, okay? And then we should have a dictionary by size. Dictionary and a size and basically list of T of the specific size. Yeah. So that will be basically oh, okay. But now let's actually create a class bucket. Okay. Actually doesn't have to be public. Let's make it private for now. Bucket of, that specific type. Okay. So it'll basically have a list of those arrays. Okay. And it also should have. Oof. So let's make it a bit different. Because the whole idea is that we're moving which bucket is available, which bucket is not available, and all that. So we should have kind of a list of arrays of of buckets that are, you know, in place or not. So maybe we should actually have a T and, you know, 5, whatever. And then another list, it'll be a list of lists that will be free bucket, free arrays. Okay. What the hell am I doing? Free arrays. Okay. Whatever. We just make that it's new. And what the heck is going on? There we go. So disgusting. And then we'd have private T, whatever. I know it's wrong right now. And this will be rented arrays. Okay. And this way we'll be basically able to move them around. We just need a count. Private int free count and rented count. And go away. And this way we can create those buckets and just have something there. Okay, that works. So we want to define that we have this, and therefore we have an array of that, right? It just doesn't like something. Must contain at least 2 elements. Oh, we just define it like that. Okay, that works. And when we it's not valid class for bucket. Internal? Why can't I make it private? Weird. So basically we could have something like a list of bucket of tea. Bum, bum, bum. Okay, that looks better. That will be the pool. Okay, I'm happy with that. So let's think about the bucket. We want to be able to rent, and we want to be able to return, and we also want to be able to, you know, create it properly. At the same time, we don't want to be running around between a bunch of buckets to see if you know, we want it optimized, right? So let's think. Public, whatever. I don't know if public is possible here. Bucket and integer will be arrays count and array length. Okay. And we're gonna basically pre-assign them. Let's just add a little bit of description to have some context. A bucket of arrays of a given exact length. Okay. A whatever. All arrays are pre-allocated for instant reuse. Okay. when we're giving, and how the hell are we keeping track of those arrays? That's a good question. I guess we have the... Huh. Do I need to have like a dictionary by their pointer or something? What the heck? How do I do that? I never did that kind of code. Um, we'll get there. We'll get there. Hmm. Hmm. Let's see what happens. Um, so we basically do 3 arrays. And we just do this. Rented arrays. Huh. Okay. Just a number of them. Okay. It's just pointers. Now for that many, we basically need to do, yeah, reallocate, right? And let's do free count is this, and this is 0. So we can just do that. And this is just not used, so it's unhappy about that part. Okay. Always assign before being used and can be converted into local variable. Not yet. So then the whole idea will be that we do public t rent. Okay. So we'll be able to rent from here. And that would basically grab a free array. So we're gonna grab from the end, I guess, or it doesn't matter. I will grab from the end. So we're gonna do if free count is larger, less than, free count is larger than 1 or larger than 0, right? Because we need to get anything. Or if it's 0, I'm gonna throw an exception, okay? Throw no phrase left in the bucket. That's the bucket, not the pool. So that will be that part. And I'm not making any thread save yet. We don't want that. So now we need to grab the array. Okay. Is free arrays. What the hell is minus minus? Huh? What? I haven't seen something like that before. Double negation? Or is this some kind of weird C# thing? What is the minus minus in the following C# code? It's a decrement operator. Oh, duh. Yeah, it decreases the value of its operation by 1. There are 2 forms. Yeah, prefix decreases and then returns the value. I don't like that. I want to do it separately. Okay. And then we do this. Okay. That's much cleaner, more understandable. No weird shit, please. Okay, so we get our free array. Do we need to keep it and rent it? I wouldn't say so. This way we don't have a real pointer to it. We don't have more data defined or whatever. And therefore, if somebody forgets to return it, it's gonna go away. Okay. I'm cool with that. It would be kind of nicer if instead of arrays like that, if we could simply have one big array and just move around with spans. Because that means we have just one object of specific length. All copy and paste wouldn't be, doing much. Although then we want to clean each array or whatever. I guess that's what... Interesting. Because this way we wouldn't need to manage a bunch of stuff. We just have a span, okay? And we return a span which already tells us whatever we need to know about it. But then if But then we wouldn't be able to differentiate between buckets. Let's ask ChatGPT one more thing. What are spans exactly? Is it a value or reference type? Spans, yeah, it's memory safe, blah, blah, blah. Read-only counterpart of read-only span are designed to improve performance. Memory safe, type safe, and lightweight. Avoids heap allocations, which can reduce garbage collection. Span is a value type. This means that are located on the stack or inline other structures. They're in the heap, so that's good. Can be more performant. Blah blah blah. From stack allocated memory. Oh, that's interesting. You can stack alloc, huh? The span is stack span, stack alloc. Oh, okay. And then we have all that. This kind of converts it, huh? And we have span slice, and that just returns another span, right? Working with read-only span. Do spans retain some kind of link to the array they originate from? Yes, they do. Okay, retain reference to the underlying array or other memory buffer. This means that changes will directly affect the original array and vice versa. Okay. Doesn't copy the array's data. Yep. And an example and whatnot. Okay, so it basically contains a reference. That's good. Can you extract the array reference out of the span? Okay. Expose the underlying array. If you need to access the underlying array for some reason, you would need to keep reference to the original array separately. That kind of sucks. Uh, do spans have some way to identify slash differentiate them? Basically, if I create two spans of the same start and position on two different arrays, can I uh, are they considered equal? Or let's see. Quality is based on the content and not the identity. Oh, okay. Okay. Hmm. So even though these are two different arrays, they will basically say that they are equal. Huh. Custom comparison for identity. If you need you would need to implement a custom comparison that includes the array reference as part. It's an example of how you could do it. R equal, R spans equal, blah blah. Oh, you need to provide the arrays to them. Seriously? Hmm. I don't like this. We could as well just use separate arrays and just have them pre-allocated, right? I was just thinking that maybe if we would have a situation where we have, we can return spans instead of actual arrays to, go through things. And we could return those spans and, just clean up the stuff and continue. Hmm. But when we would basically return it, we wouldn't have a way to identify to which array that span belongs, or you know, uh, we wouldn't have a way to keep track of them. One thing would be to have little IDs with them, and that could solve the problem. But then, because of that, we're just storing more data, and that's more data per each. What do you call it? Frozen state. And because frozen states were being deleted quite fast, I don't think we. I don't think it's a good idea. Hmm. Even though we're reusing this stuff, we wouldn't necessarily decrease the memory usage. We potentially could increase the speed, but again, not necessarily. Hmm. Yeah, I'm kind of not liking it. And just having one gigantic array wouldn't be a good idea either. Okay, this is not a pleasant problem. um, let's continue with this a little bit then. Let's see how that works. So we have the way that we can just predefine all those arrays, right? We're good with that. This way, each array has its own little ID and whatnot, so that's good. I guess that causes chaos, but we can live with that for now. Okay, so we're fine with that. Next. So we have the bucket creation, and when we're renting, we basically take the array, no free arrays left in the bucket. If there is, just grab it, decrease the number of free. And we really want rented count to be just kept track like that. I guess we could. This way we don't do. Yeah, sure, it's gonna be good enough. Because the other option will be to keep the. Oh, sorry. To keep basically the number of arrays that we defined, but we already have the length of the free array. And this way we're just gonna get rid of an extra calculation or something. Or do we even need the rented count? We don't need the rented count at all. Yeah, let's get rid of that. We don't need it at all. We won't ever access it. We're only interested in the free count, okay? So that's that, and we just need to return array. Bam. So that's the rent one, okay? And then we have public void return that array. And we, at this point, we trust that we matched it properly, okay? So, but how do we know where to put it back? Oh, we don't have to, right? Because yeah, because we're not really storing them here. We're only storing references. Oh, okay, that changes so much. Holy moly. We're just keeping track of references, and we just have slots for references. So yeah, so we could just do if it's back here. Oh, that means we don't even need to worry about keeping track of, having like a list of those which were rented, which we didn't rent and whatnot. We just keep. Oh wow, this is okay. This is gonna be simple after all. As long as we can get to the pointer or the ID of the reference. So we've got that, and then what? We don't even need to compare those references. Yeah, whatever. So we do basically. Yeah, we pre-create all of them. Or do we want to even create them, pre-allocate them? We probably don't even want to pre-allocate them. Yeah, that's it. We don't want to pre-allocate them. We'll basically allocate the next one when we need one. So we'll just call it free arrays, right? Free count is gonna be decreasing. No, let's pre-allocate them, okay? Let's just have them here initially. This way we don't need to track of how many we actually allocated, how many we did whatever else with it. So that's gonna be fine. Okay. This is good then. We just take it out. The important thing here is that we want to remove it from the array, right? The free count, and therefore we do free arrays, whatever arrays. Free count is no. Can I convert null literal to non-nullable reference type? Exactly. Okay, this is gonna be a little bit more tricky. I don't want to wrap arrays in. Huh. At the same time, I don't want to store them there. But ultimately, this always retains the references, right? So I don't need to clear it. I just keep the reference. But when I have something returned, I just override it here. And therefore, next time decreasing, I can just get it back. Yeah. Okay, that works. It will start switching order and whatnot, but as long as the others are keeping the reference, it's gonna be fine. So I just need to be extra diligent about returning the references. Okay, so rent is good. Return will be basically if free count is larger or equal, we don't need to do those tests, all right? Let's not do those tests because the whole idea is that we're making them somewhere else first. Let's just trust whoever's gonna be calling it. That's why it's gonna be only available through exact array pool. So when we return it, we basically take the array and we're just gonna do free arrays. We'll just do the free count is that array, and we can just do free count plus plus. So we're gonna increase it first. Free count plus plus. Okay. We're gonna increase it first so that we can assign the array there. Okay. And that's it. Okay. We don't need to do anything else. Okay, this is nice and simple. I like it. So next, in the chat stuff, nothing in chat. Guess people don't like talking to me. Okay. Cool. So let's consider that the bucket is done. Okay. Non-nullable field rented arrays is uninitialized. Oh, because we don't need it, nor that one. Okay. That's all we need. Arrays can be made read-only. Sure. Okay, so that's good. So if we have that, that means we can have just a list of buckets, and we start with no buckets, and we can keep adding them if we need more. So so when we created, right, the exact array pool, let's not make it static, right? We'll make it civilized, normal. Exact array pool. So when we create it, we don't need max array count. We don't need array length or anything. Let's just do integer arrays per bucket. Okay. And what we're gonna do is we're gonna hold the whole private. This will be private as well. Yeah, erase per bucket. So erase per bucket is this. That's good. And that's all we do for now. This defaults to something, so we're good. Um so now it would be nice if we could just not need to do a bunch of checks if this exists in a dictionary and all that stuff. How do we avoid that? With try get or something? I guess we could do that. um public, and we do the whole rent, right? Array length. Mm-hmm. Hmm. So now we basically need to do the management of buckets first. Okay. So let's do pool dot try get value, right? And that basically returns a list of buckets. Oh, yeah, this kind of sucks. So let's do if not. I mean, if it works, we basically do that. So then get the list. um, if it's 0, um, hmm, we actually would need to store not only the list of buckets, but how many buckets. I mean, how many overall were stuff. How much stuff we have, and keep track of them. So let's actually make a little wrapper for those. So we're gonna do internal class bucket set or whatever, bucket list. Okay, that's actually funny. Um, so we're gonna have a list of buckets here. Okay. And we're just making a new list. Okay. No big deal. And then we're gonna store basically private price per bucket. I guess we need to keep that in check. And then we have private. Oh, we need also to store the length. Array length. Okay. And then bucket count, right? Okay. And we're gonna do rented count. Okay. The total count of how many we rented, and from there we can start calculating how many more buckets we actually need. So public bucket list. Yeah, we just assign those. And we don't add any buckets yet. So then we're gonna have the rent, and this is when the magic is gonna happen. So basically we need to calculate if we need to create a new bucket, or like which one we need to access. So let's say var bucket index is rented count mod the arrays per bucket. Not, I mean, rented count plus 1. Because we're gonna rent another one. Okay? This will tell us, or no. Because they start at index of 0. Yeah, so this will be the bucket index. And if buckets count is less than bucket index, we're just gonna need to create it. Bucket, add new bucket, raise count and array length. Perfect. So we're gonna have the bucket added, and therefore we can go and do stuff. Our bucket, which is bucket, right? Just bucket reference. Of type T, of course. All right, so just do bucket is this, and we just add it there, okay? Else, we'll just grab the bucket, okay? That means we kind of don't even need to track those. Huh. Interesting. Okay, so we just run the bucket, increase it, and redo that, and that's it. Okay. But now, if we want to rent, we want to specify the ID. We could calculate it here or store it there. Let's store it there so we don't have to calculate more stuff, right? Because here we're just doing increase, decrease, and that should be fine, I guess. I know writing will be suddenly more difficult, but we have it working. Let's continue that. We can troubleshoot it later. And return. Basically, will be, again, calculate bucket index. And that bucket will exist. So for bucket is that. Return array, rented count, decrease. Why would it increase when we return it? So weird. Let's not worry about deleting the buckets yet. You know, let's not worry about it. I think. I mean, we could add like a thing to clean up or whatnot, and that wouldn't hurt, I guess. But we'll worry about it later. So again, we have rent and return. Yeah. So on the pool, we'll just call it bucket list. That looks so much better now. Arrays per bucket, all that. That's good. So we want to rent this. We get that, and this will be a bucket list, right? And bucket list count is larger than 0. We're not doing that. We're just getting the whole bucket list, right? And return. We got the bucket list. We can just rent it and return it, right? Possibly no reference. Why I'm doing the try get? Maybe null and false. Yeah. Out value, value. What the heck? It's not. Oh, that's probably why. So if that's the case, but if it's not, that means that our bucket doesn't exist. So we basically need to do make new bucket list, add it to the pool, and return a rented. Okay. Array length, bucket list. There we go. Yeah, that's good. Cool. So this will be renting, and then we have return. Da, 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 da. So we calculate that. We try to get the value. And if the value doesn't exist, I mean, it exists, okay? It for sure exists because we just got it. So we just returned it. Duh. So we can just do full array length, return this. We know. Yeah. By the time we get to returning, the bucket list is already in the pool. Okay, so that's good. Good, yeah, good. And the same thing can be here. By the time we get to returning, the bucket is already in the list. Cool. Cleaning up later. Right now, I just want to test if it's gonna work or it's gonna just completely screw everything up. So we have an idea of the exact array pool. So what we could do is what I would do in a program. Hmm. Not really liking it. Let's just go to exact array pool and let's make the whole thing like that there's a shared one. Okay? We're just gonna make it that this public static. Oh, hello, Hung Leviet. May I know which theme you are using? Sure. This is Writer, and I believe this is the Monokai Pro. Yes, Monokai Pro, but it's the filter spectrum. Monokai Pro filter spectrum. It's just in a plugin marketplace, Monokai Pro, and it just comes with a bunch of them. I like the spectrum because it's a bit darker and still fun and colorful. I like that theme a lot. I wish it was in VS Code, but in VS Code, it's actually you need to pay for that, so that sucks. What was I doing? So let's make the static like shared pool. Okay, shared. Exact array pool. Okay. T shared. And let's just make it new. What the hell do I erase per bucket? I'm just gonna make it Yeah, you're welcome. Always happy to share. So let's say that we say that there's initially, the 50 buckets per pool, right? So that means that when we, that the pool is gonna get created so we can use it. But then when our program finishes with all the bunch of weird stuff, we're just gonna clean it and let's make it like reset the whole pool or whatever. Exact array pool. We're just gonna add quickly. You know what? I'm just gonna move this whole thing to the bottom. And let's call it like section shared whatever pool. Okay. We have the pool here, and then we can make it like public static, and we're just gonna make it void, of course. Reset pool or reset shared pool, and this is gonna be basically let's reassign it. Okay. Screen type. No, that's good enough. This is gonna be. Let's just add a node that's completely remakes the pool. Can be dangerous if you don't know what if things whatever if what do you call them if something references arrays in the old pool. Okay, because the whole idea is that somebody might still be sharing stuff from the other pool, and now they're gonna try to return it here, and that'll be not great. So yeah, okay, that is problematic. Yeah, let's not use it yet. We're just gonna make it that our frozen state, whatever, instead of using this array pool, we'll do exact array pool. Will be bytes shared rent and array length, and we want our array length to be initially 0. Okay, I hope I'll be able to allocate 0 length ones. But that's that. Okay, let's keep this one here to be the way it was. I just want to see if we're not gonna start tanking performance or something. And therefore, when we're doing this whole thing, we're not doing that yet. We want to have the exact array pool, blah, blah, blah. We return it, so that's good. And here in append, we just need to say that exact array pool. Yeah, so we're gonna get our exact arrays. Awesome. So that's good. And here we are not using new code yet. I guess that's it. And let's see if it runs or just crashes or what the hell happens. Errors, errors, errors. Of course there are errors. Index out of range of the bounds of the array. Exact array pool line 25. I can't control click really. Line 25. What dumb thing are we doing here? 25. Pre-erase and get it. So wait, this is rent. Inside a bucket. Recount. Ah, I see. -1. Duh. But that means that when we're returning it, yeah, when we're returning, I'm gonna be increasing the ID afterwards, okay? Let's try to run again. Another error. But a bit later, I think. Wait, the same thing? What? Um, when we create it, the free count is select the arrays count. Okay. And we define this whole thing and go through all of them to create the arrays. What? What's going on? Why can't we? Let's debug this damn thing. Creation and then renting. Unless we get to the point where free count is 0 and that's our problem, but I don't think so. So yeah, we get to creation. Array length is 0. I wonder if for 0 we just should have nothing there, whatever. And the arrays count is 50, all right? So what's my F8? We just create an array, right? Free arrays. We have 50 of them, right all the way to 49. So we're good. And we whatever this, and we go through freaking 50 of them, right? Yeah. Around to here. Okay. We continue and we encountered this guy. We want to rent. And our free count is 50. Right? So we should try to get an array of 49. We got an array of 49. Okay. We do that and we'll return it. Oh. Okay. So that worked. I guess this is gonna be a weird case where something just doesn't work. So continuing, we have what? We have 50 of them? Did we just call return or something? It's 49. Let's just mark here that we return or whatever. So we went through that. Okay. Resume. We didn't return, but free count is 50 again. Are we just going through different sizes of arrays that we want to request? What's the... I guess we don't have access to the size now, right? We're in here. And here. Frozen state. Yeah, we're just requesting 0. Yeah, because we should request a bunch of them right now. Okay, that's confusing. How are you doing, Hang Leviet, by the way? Because I can see you're watching, so how are you doing? Is it morning for you? Is it night? Why the heck does it reset every time? Can I go to our shared pool? Right. Our shared pool. Does not exist in the current context. Okay. Our bucket list does it? No, not in the current context. Great. Sure. What kind of array did we get? Of 0. Okay. I just don't understand why we're constantly getting a free count is 50. What's going on? Because that means that we're just getting to nowhere. Rented count is also 0. What the heck? And that's an array of 3 by now. Okay. So what the hell's gonna be next when we rent it? Array of 4. Okay, so that's good. Next one is array of 5. Yep. Yeah, we're going to the right in the thing. 6, and we should get to 7 now. And the last one will be 8. No, 7 again. What? Then why is it still 50? I mean, now it's 49. Now we get to another 7 probably. Oh yeah, because we got to the end and we're just adding all the 7s that are conflicting, and therefore now we're gonna start going through them probably. All the 6s and yeah. So why is it that we're just suddenly unhappy? How the hell do I debug that? Huh. Let's just move the stop to here so that we can see the length of the array every time. 7, 7, 6, 7, 7. And free count is constantly at 50. How is it possible? What's going on with the free count? Am I like adding a bunch of new things? We go back to rent here. We're in a bucket list, okay? Inside the pool thread. So let's look at our pool. We have 8 of them. Okay. For 0, arrays per bucket, array length, buckets. Oh, we have 3 buckets already. So that's our problem. We're creating buckets non-stop. Yeah, each one has... Yeah, so for 7, we're just gonna have... freaking 26 buckets. Okay, there we go. Found the problem. So let's get rid of, this guy works. Bam. Bucket list. So when we have rent, we calculate the bucket index. Rented count. Okay, we increase it. Okay. The rented count mod arrays per bucket. Yeah, that should be good every time. So let's just go here. And if buckets count is less or equal to the bucket index. So initially 0, right? If it's 0, we're gonna do this, but then it shouldn't be afterwards. What the heck? Okay, we rent. And bucket index 0, arrays per bucket, rented count. Okay. So we're gonna go correctly here. Bam. And yeah, we have the bucket. And then we're gonna rent from the bucket. And we received a nice byte 0 size, okay? So we fast forward, we have another request, and that should be another 0. Rented count shows 1. But bucket index is 0, so that's good. But buckets count should be 1. Okay, so that should be fine. If it's less or equal. This is 1. Wait, why is bucket index 1? What the heck? Because raise per bucket 50, random count 1. Wait, this is a remainder, right? No. What the hell is going on? I'm getting confused by just the basic stuff. So you could get a reminder, or you could get a... What the hell? Because this should be modulus, right? Bar. Bucket. Index. Oh, if we divided it... Yeah, that'll be better. Yeah, that makes more sense. That's how I would do it normally. Jeez. Run it. Now it's gonna work? The way it should? Attempted to divide by 0. Oops. Array length. What? Where did it come up with this? Jeez. Out of range exception. Extract at 74. With return. How? Oh, the. Okay. Index out of range. Parameter index. Again, 74. What is going on? So let's debug it again, okay? Let's make sure that our indexes are fine. Okay. So here our bucket index is 0, and therefore we create it, okay? It's all good. Random count goes up, we return the array, and we add it, so buckets has one thing in there, okay? So we continue, and we've got another one. Bucket index is still 0, but the count is 1, so we're just rubbing the bucket, right? And we got the bucket, okay? And has 3 arrays in there and all that stuff. So we're good here. And yeah, continue. Another one that's gonna go out here. Another one. So yeah, this one will be probably less because this is just increased to 1. Okay, so we're gonna continue. We're gonna be skipping those. And what I want to do is capture whenever we get in here. Okay. So here we basically are returning a byte 11. Oh yeah, the array byte 11. So we're gonna get here, bam. Bucket index, what? Huh? How did that happen? Erase per bucket is 50. Rented count is... Wow, okay, what the hell just happened? What? How many buckets do we have? Okay, we have a lot of buckets. Okay. 2309 should be in here. Okay, good. So we'll be able to return it. Free count is 0. Free count. Oh, look at that. This is not good. Because we're not returning free counts the way they should happen. That's strange. So we're gonna go here, return, and rented count goes down. And therefore, when we go to buckets, and that 2309. Whoa, what? There we have more? So many more? 2309. Free count is 1. All the other ones, why do we get to 2309 randomly? What just happened? Why are we losing track of those indexes? Because every time we rent, we increase it by 1. Every time we return, we decrease it by 1. So what the hell? And all those buckets were filled in, so that looked fine, but okay, this is slightly confusing. It's more like we were decreasing the rented count a little bit too much. That doesn't make sense. Do it once. Okay, debug. By this time, we're here, we continue 2276, right? Bucket index. Because it says 50 buckets per erase per bucket, rented count, that many. And yeah. But how many buckets are there? 2, 2, 8, 4. Each one shows that it has free count 0, free count 0, free count 0. The last one has 36 left. 0, 0, 0, 0. So they're filling up properly. But I wonder if we're missing some numbers because we have up to 2283. That's how many buckets we have. And randomly we have that number. So we're clearly not tracking well of that rented count, or I suspect if we're freeing or adding something to the specific bucket. No, it shouldn't be that way either. What the bleep? So when we go up, basically rented count goes 0, it'll be 0. 1, 2, 3. 49 should still return 0. right? So let's do this, but let's make it conditional. Rented count is 49, okay? So let's do that. And this is 40. What? It's supposed to be 49. Not L. What? 13,000. I mean, 11,000 something. What? Um. Okay, that goes bucket 227. How many buckets do we have? Exactly 227. We have still 7 left in there. Stop. Oh, we got to the return, but oh. So if we have condition rent count is 49, how the hell did we get to the point where somewhere else we have 227 buckets without ever reaching rented count being 49? What? If rented count is 49, console right line, rented 49 buckets, whatever. Okay? Turn it. I mean, rented count is 49. Okay? That's the thingy. Okay? Well, another one will be here. Because I can't believe that this wouldn't happen like that. Debug. Now it detected it. With rented count being 49. Okay, that's better. So, yeah, ignore that, whatever. So if that's the case, the bucket count is still 0. And in our buckets, we should have the last one. Yeah, the first bucket, 1 free left. Okay, so that's good. So that means that part is working correctly. Ay. So what the hell is wrong with returning it then? Why the rented count just goes wonky? I could return array and we don't need anything here. We just decrease it once. Okay, I'm getting confused a little bit. When we return, free count goes up. Yeah. So what the heck is going on? We have some big problem here. It's very strange. Very, very strange, I must say. So we created, it's all good. We just have empty pool. When we rent, it's all good. And when we return, we don't even check as what. We just get the pool and ask it to return. And the pool keeps track of everything. So I really don't understand how. What the hell is the problem here? It's all accessing the same thing anyway. the bleep? Yeah. So array pool 107. 107 will be where we're calling return, right? 107, we call return. And we go to line 74 when we get the bucket. And for some reason, the bucket doesn't exist. But what was the idea of the bucket? How about that? Can I just debug and see what happens? I don't think we're gonna get much info here. Recount. Okay, so we are inside the specific bucket. Recount is 50. 3 arrays. Index out of range. Index was outside of range. And it would try to get what index? Recount is 50. While we're trying to return extra? Why are we trying to return here while... Oh yeah, because we targeted the wrong bucket. Yeah. If we were here, we would see that for some reason we get the bucket 227 while we already have... Yeah, 227. Hmm. What is going on here? Because those numbers just go wonky all the way. Stop. Well, let's just freaking print out everything. Every time we print in and out. I mean, do this stuff. So, let's do it that way. In a bucket list, we're gonna do whenever we rent, before we return the array, console, write line. Okay. We're just gonna do rent. So let's just do like not the rented count. This needs to be basically the size of the array, right? Array length. We're keeping track of that. Yeah. We're creating new buckets. Okay. So array length. Rent. And this will be number and rented count. Because that just increased. And then when we return, we're going to do something very similar. Let's just do arrows. Rent will be back. For going for returning will be in here. So let's run it and see what happens. What? 10. 10. Okay, 10 is 70, 80. Returned. 79, returned. 78, 77, 76. All that is good. Okay. 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7. Yeah, we're just doing all those. Do we? Yeah, they increase. That's all good. And they decrease gradually. So all that just makes sense. I didn't do anything like multi-threaded, so what the hell? Hmm. Okay. So if I go to console, this is returning array of 10. So we had 7606. And we just need to get to the where the hell is that thing? Here. 7606. Right? Yeah, so that's good. Bucket index 152. Okay. How many buckets do we have? 152. So that's so good. Free count is 44. Well, the errors here. Um, free count is 44. Why can't we get to the number 44? That's assigned here. That's assigned here. Free arrays is freaking 50. The free count is 44. Item out of range. What? This is a little bit confusing. All those arrays are of size 10. So that's all good. And I can't assign the number 44. Huh? This is a mystery. You have an array of 50 arrays, right? If you have 50, you want to assign to the number 44 with the fitting array. But it's just like, nope, it's out of range. What? What just happened? I don't understand. Cast helpers. Not available, blah, blah, blah. Okay. I don't think I ever found an error like that. That just doesn't make sense. Hmm. And it worked probably 30,000 times more before that. Are we getting some kind of race condition? Because I don't see another explanation other than some kind of race condition. But we have everything in a single thread. Hmm. Yeah, and a frozen state, we create this, that. Okay, I must say that's a new one. Is it going to crash at the same spot? Recount 43 this time. An arrays of 10. So look at that, it just varies from time to time. I'm gonna debug once more. Huh. This time it's 0. We're trying to get to 0. I want to return it. Okay, that makes sense. And we're in here, so we have bucket index is this. So the count is, oh, this time we're going to 11. Okay. 76547. Yep, that's the one that we just took. We want to return it. And bucket index. Where are the buckets? I think bucket index is 15, 27, 29. Oh, this one just still has 3 left. What? It's as if some of those like return or whatnot, they just happen a little bit later. So why do we have like multiple threads? Get next plan, all that. Yeah, that's the main program. Get next plan and all that. Okay. Well, this is a separate thread that. Oh, I see. Oh, wow. That's actually super kind of obvious. Oh, wow. So the thing is that we're returning stuff when we call the destructor. And destructor is basically called by the garbage collection. And something tells me garbage collection, at least this kind of indicates that garbage collection happens in a separate thread or straight up in a, like multiple threads at the same time and just calls a bunch of stuff that to return stuff. So we would basically need to make sure that when we're returning, we're properly locking and whatnot. Okay, that actually makes so much sense. So to make it thread safe, we could just use good old locks because we really want things to happen in order. So Let's stop it. And I think this is gonna solve it. So in our exact array pool, we shouldn't worry about creation because creation happens in order, okay? So our buckets will exist and we don't have to worry about them. So we don't need to make locks like on the whole thing. What we would need to add locks to is to the bucket list, because the bucket list is the one that manages the main rented count and all that. So basically when we rent, we want to lock the whole thing. And when we return, we want to also lock the whole bucket list. So let's quickly ask ChatGPT how to deal with locks. And let's do it in new conversations just so that we don't have the old context. Okay, so we're gonna do something like I'm working on a C# code. I have a class bucket list, okay, that has two methods, rent and return. I need to have a shared lock so that when rent or return is called, all the other calls to any of them need to wait. Okay, something like that. Lock or semaphore or whatever is suitable. Okay, let's see. Semaphore slim. This will allow you to ensure that only one thread can access the rent methods at a time. Here's an example. Okay, and semaphore. Why semaphore? Initial count of 1 and maximum count of 1 is created. This acts as a mutex, okay? The rent and return method acquire lock before this and that. The main method. What's the difference between standard locks and semaphores? Okay. So normal difference is that their usage patterns and capabilities. So standard locks. The lock statement, which is syntactic sugar for monitor enter and monitor exit, is used to ensure that a block of code runs exclusively by a single thread at a time. It's typically used for protecting critical sections of code that can access shared resources. Okay. So ensures mutex exclusion, only one thread can enter the critical section at a time. Simple and straightforward, does not allow specifying the number of concurrent threads. Okay, always one. And a semaphore is a more generalized synchronization primitive that can control access to a resource by multiple threads. It maintains a count that represents the number of threads that concurrently access the resource. So it has counting, can allow more than one thread if allowed, okay? And flexibility suitable for scenarios where you need to limit number of concurrent. Slim version is lighter in process version, better performance, blah blah. So mutual exclusion, protecting shared, semaphore, limiting number of concurrent reads. Huh. Why do you recommend using semaphore slim in my particular use case rather than lock? I need only one thread to be able to access it at all times. Avoid race conditions. Da, 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 da. Simpler, more straightforward, given your requirement of race conditions. Yeah, that should be fine, right? We just have the lock, a single lock instead of whole semaphore. This will be like, we want performance. Okay, let's do that. Let's just add a damn lock. Returning happens, is triggered by GC. So we need to make sure we don't, what would you call it? Race conditions. Okay, let's attach to this. So we have our lock object. Why object? Does it need to be an object? Do I have to use an object for the lock, or can I use simply some other variable, like an integer? Because that will be nicer. Require the reference type. Okay. So we're just gonna do that. So I have our lock object, and we just do block and a block. Cool. So when we rent, we use rented count already here. So we're gonna do lock, our lock object. I need to shove everything here up to here. Okay. Because then we can return an array, no problem. Okay. Yeah, let's have that here too. And this will be also lock. There we go. Let's see if that works now. A different line, 84. It's gonna be the same thing, right? Seriously. Oh, now it's here. Again, return in the bucket itself, but we're not allowing for multiple buckets to be accessed at the same time. So how is that possible? Free count is 50, but we're trying to add more, right? That's the problem. Okay, so that's a different kind of problem. And we're here, we have the lock object and whatnot. So we get to iteration, whatever, bucket 2274. Where are the buckets? How many buckets do we have? 2274, that's good. I want to return it. So looks like we have some problem with the counter. because they're all filled. So let's think about it. We start, we rent something for the first time. We get we get nice 50. We rent it in our bucket, rent, and it decreases to 49. And then want to return it, we access the object 49. Oh, we try to put it as 49, right? Because here we're doing this. So we could actually do it like that. Okay. So it'll be 49. Okay. And when we put it back, we add it to 49. Okay. So now, why did that thing want to go to that particular bucket? We're gonna probably get a different error. Oh no, free count is 50. So why? Now we're going this return. Bucket index 2277. Buckets count is 2278. Okay. So we got a bucket that's basically full. Well, buckets should be one more in this case. Oh no, buckets count is, yeah. So we have bucket 277. Bum, 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 bum. So how is it possible that we have 50 in here while we're trying to return something here? Because we're not deleting any other buckets. And the whole process of renting, which could make it happen that we create a new bucket, right? Happens during the lock. Therefore, when returning, you can't create more buckets. So we want to have that race condition here. Interesting. So how does it happen that we want to return the same thing? Because rented count decreases during the lock and increases during the lock. Nothing else can happen outside of the lock other than creating a bucket list, but that's a completely separate thing. I mean, in theory, we could make the whole dictionary here. Can we do concurrent dictionary or something like that? But that's gonna screw something up, right? We won't be able to add triad. Okay. Oh yeah, try get value. This that. Huh. This might be actually. If it doesn't exist, create it, right? So let's just make sure that we have it. If pull, try, whatever, add or get. Oh yeah, get or add, right? And this has the key, right? Which would be array length. And then value factory, which returns a new bucket. Da, 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 da. right? We need the function t key t value. So it takes key and a value factory. Yeah. Should take, wait, value? No, just types. Okay, so it should take in the key. Sure. So that with the length, right? But we don't need to worry about it, or we should. So let's do length. Okay. New bucket list. Erase per bucket, and we'll just do length. And that will be it. Wherever the count came from. The hell? So we just have this and no ifs. We'll just do the var bucket list is this. Hey, this is actually gonna kind of simplify our code. That's nice. And therefore we just do return rent instead of this whole thing. How lovely. Sure, but yeah. Is there like pulled on get? No, that shouldn't be a worry. I don't think that's gonna fix an error. I will be very surprised if that's gonna fix something. Yeah, we're getting the same damn thing. Wait, we're in here now. I'll arrange. So we try to get a bucket 1552. Well, there are 1552 buckets. When returning, how is it possible that we're returning index that doesn't exist yet? Or locks don't work or something? What the heck? Okay, this is just starting to be really confusing. There's a lock here, right? Period. Do I need to use whatever ChatGPT tried to suggest earlier? That use semaphore? Well, that should work the same way, right? But just in case, let's try, okay? Let's just try semaphore slim. We're going here. Bucket list. So we have our semaphore slim. And all that fancy stuff. And then we'll just do semaphore wait, do your stuff, and semaphore release. And an ugly try catch. Okay. So we're just gonna comment this guy out. Have our try. And we'll just have the same thing here. Right? And then for both, we just have finally block. Bam. And bam. That's gonna change anything. I will be deeply confused. It didn't. Try to return something that doesn't exist yet. I guess we could go with the thing that I tried to avoid, which is put a lock on the whole thing. So let's try one last thing. Let's just hide bucket. In bucket list, we're gonna take the semaphore out of here. And we're gonna go to the whole extract exact array pool. I mean, we shouldn't have a problem with it being single threaded. The whole thing is single threaded. It's just like, I'm not happy about it. Bam, bam. And we just move to the exact pool. We have rent and we have return. We just need to get those blocks out of here. Bam. There we go. And quick cleanup. There we go. So we just place it here and here. So ugly. I mean, this should work, right? This should make it thread safe, let's call it. So let's try if that makes any difference. No, it makes no effing difference. So I guess locking fixed some stuff, but we still have an issue of not adjusting some kind of counter that causes this whole thing. So let's get back to the point where we were doing whenever we rent something, right? And I'll do it from the bucket list. So whenever we rent something, we'll just do console right line. I'll do rented number, bam. And here will be return. Because they should be in order. Yeah, we got to that point. So everything is in order. We rented 49, 50, 51, and now we're trying to return 54, 350. Wait, yeah, 54, 350. Wait, we rented 54. Oh, we returned 51, and now we want to return 350. Right? That's good. Bucket index for it is calculated to be 1087. And we have how many buckets? 1087. That's the last index. So we're good, right? Problem is, it has 50 in there. How is it possible that it has 50? So that specific bucket. Do I need to add those damn thing to buckets that I'm counting buckets? That would suck. Gosh, it's late. Free raise. It's all good. We rent, we decrease. We return, we increase. And why on earth? $49, this, that, not, and then we have 0. And we're not checking for zeros, right? We shouldn't even need to check anything. So let's to the bucket, right? So let's make this free count to be get private set. Okay, let's not worry about the name for now. And the bucket list. So we rented this. So we're do bar bucket free count before and bar after. Oh, go. And we'll just do bucket free count before and after. Okay. And then we're gonna do same thing here. You get the bucket before and after. What the hell's going on here? Eleven. We get to 50 anywhere? From 49 to 50. Never return. It nicely increases. Okay. Returning. Still returning. Wait, these are 10s. I want 11s. 21, 11. Rented decreases it. 22 to 21. Okay, here's from 22 to 21. From 21 back to 22. It all works. So what is the problem? 11s. Where's some kind of threshold? Because maybe that's the first time we're actually encountering some kind of threshold. Hmm. Let's think. So if is it some problem of like returning probably? Let's think. So normal bucket, we're just doing that. And decrease. Go down to 0 at that point. You have 0. And then we want to return. You should have the 0. Bam. And return 0. Bam. It should never go another way around. Yeah. And then we have our bucket list. So the thing that we retrieved the specific number. Wait, when we rent, bucket index is already rented count. Blah blah blah. Blah. When we return to get to the same thing, we should rent account -1. But how would that impact anything? That might impact it when we're going from one bucket to another, maybe. But I don't see how that would work. Oh, it might just have fixed everything. Okay, progress. So let me just get the semaphore out of here so we can attack multiple buckets at the same time, because I believe that will be just a smidgen more performance. Bucket list. Wait, what? Here. And actually, instead of having semaphore, we're just gonna get back to our good old lock object. And therefore, here we can just do the simple lock. You go away. You go away. And here we'll have the what it will be lock lock object, right? I'll have the same thing here. Let's run it. Okay, that looks good so far. We're just printing a lot of data, so it's going really slow. Let's stop. Let's comment our printing out so far. And we can, yeah, let's just keep it like that for now. Okay, we're moving forward. It just seems like we're going real slow for some reason. I wonder if we're doing some extra allocations because of this whole management of whatever. We'll see. But we're finally gonna get some tests, like test results. It's just going really slowly. Holy moly. God, we're getting just to 102. And big slowdown. What the hell's going on? I wonder if it's that just locking and unlocking of that whole object thing. And I wonder if we're gonna get different result as well. I haven't counted how many results are conflicting or whatever we got. Because now that we're requesting new array, we're reusing some of them and therefore we're not cleaning them. Gosh, it's taking a really long time. And it tells me that a whole exact array pool was just not a good idea. And would also make the whole multi-threaded thing that I'm thinking in the future for not a viable option. Gigantic slowdown for no reason. What the hell just happened? Okay, we're already higher than we were before. Hmm. Not very good. So I'm gonna add it anyway. All right. Yeah, we can just do it that way. Sure. So this will be the exact array. Let's do array. Cool. Got the same number of iterations. Time was unfortunately 282978.38, which is horrible. Absolutely horrible. Now, do we get any more problems? Do we have something like append state 26183.2? Worse. Rent. Okay. The whole renting is an exact array pool. Yep. That's obvious. And then we have bucket constructor. Yep. find plans, all that, and rent also created a bucket list. Went to the large object pool. Okay. Yeah, this was a bad idea. We're gonna scrap this whole code in a second. Although, what if in our frozen state we would use this whole thing here as well? Because there'll be lots of the same week count things. Okay. And therefore we will need to clean up here as well. Okay. When we do append, just do integer array. What? Oh, we're not using that. That's not here. That's two arrays together. Go away. Increment. There we go. Here, we're getting a new array. It's from the exact array pool. We copied the old one to the new one. That's how we copied it. Okay. So nothing here, but I wanted to just make sure that here, new array. What do we do with that new array? The original array to the new array. Yeah, source to destination. Okay. And then the new item at the end. So no problems here either. Okay. But when we're initially getting it here in the frozen state sections, exact array pool, initially, we create it only once. And what the hell are we doing with it? Sections per week. This is where we would need to do something like rent and clean true or something like that. So let's update that. So when we have the rent, from bucket list from here. Array length, and we'll just do bool clean. Only will be false. Okay. So var array is this. If clean, we're gonna do there's something like clear? No, there is not. Fill. Length count array get hash code rank. What is initialize? Initialize every element of the variable by calling the parameter constructor of the value type. Yeah. Maybe that's the thing. I don't know. Return array. Okay. It's gonna add another if. So rent clean. Let's do it that way. That's an exact array pool. So that's rent clean, and this will be rent. And I won't use that either. I will just do it. And dot initialize. Oops. Oh, okay. That just does it in place. All right. Sure. So this will be just return that thing. So we're gonna make some faster code. Return, blah, blah, blah. Rent and rent clean. Cool. So in our frozen state, this will be rent clean. Okay. Alrighty, so rent clean, blah, blah, blah. Frozen state, append state. Okay. I can live with that. I would also look for some other area where we use those little arrays because we have the frozen state, but we also use it somewhere else, right? We have our planner. Our planner doesn't hold anything of value, so we don't need to worry about that. What is pending plan? It just has a number, so we don't worry about that part. Yeah, that's basically it. Huh. The combination is just that. Where do we use it? Do we create array somewhere else? Array combinations. But no, those combinations are not a big deal because we're not really creating them on the go. We just do them once. So yeah, I guess what we have now is the most we can do. The only thing I could do is here make it private again. Okay. And that's pretty much it. So I don't think that's gonna go much faster. Oh, inaccessible due to protection. Oh, we're still doing that. Hmm. Not sure it's gonna go much faster. Let's keep observing it. We'll see what happens. I wonder if it would be better to have the frozen plan instead of copying the whole thing, just pick it back. Hmm. Probably not entirely, because if we're copying that, we can garbage collect old plans there. Yeah, I think we're better off doing what we're doing now. Wow, this is going real slow. While this is running, I'm gonna take a short break. Okay, I'm back. And this thing is still going. Yeah, this exact array pool is a bad idea. Because we're not really, I mean, we're reusing some of them, but I guess there's a big overhead because we're just making a lot of really small ones. And that's the thing here. We need, you know, not the best use case for us. Blocks probably add a lot of overhead as well. Hmm. Come on, finish. Come on, nearly there. Okay. 327621. Holy moly, that's increasing a lot. 0.93. Yeah. Oof. And it comes to memory. Even more problems found. Wow. Rent. Yeah, a bunch of stuff. Blah blah. Frozen state append status. Uh 13. 749. That's interesting. But still 21 in the other ones. Hmm. No. Yeah, this complains that we're assigning stuff here. Yeah. And that we're just creating those bucket lists. I guess here it will be useful to just have where's the bucket size? Let's actually do that just quickly. Arrays per bucket. Oh, it was down here. 500. There we go. Because we going to make thousands upon thousands of objects. So let's just do straight up 1,000, okay? No big deal. I'll be very surprised if that did anything good. But it won't hurt to try. Yeah, also going slow. And right now we're probably just creating more and more and more and more. But now, yeah, this is so painful that no, we're not doing that. What I'm gonna do is just create a separate branch. Or no, this array extension is just horrible. So, um, Yeah, what did we do here? We just basically removed this, made it all look, use those array stuff, frozen state, the same thing. Plan status. Yeah. So, uh, plan status removed. That's good. Rest, discard. There we go. Remove unused code. Push. Okay. We're good. We're back to normal. After 2 hour journey of trying to make something weird work. But hey, we learned that in our case, it's just not worth the effort. So where else could we try to do something? I wanted to try. Let's just do that as well. Undo, remove unused code. So I was just wondering if maybe for a frozen state, instead of holding just an array of weak states, we would do something that I think would be more performant during the runtime, but not necessarily more space saving. Or maybe it would be because we actually have less data copied. Let's try it. Yeah. So let's make it that instead of states, we're just gonna have a link to the previous one and the current one. So we'll just do last state combination ID. And this will be parent state, frozen state. And that'll be frozen state. There we go. Therefore, when we create it, we'll just need to, like normal one, be null. And the last state would be -1. 0. Sure. Um, hmm. Selections per week are being tracked as always. Okay. So that means that I just don't like this thing being 0 or -1 or something. How are we using it when we're creating the first plan? Okay. When we have our first plans, we go over the stuff and we create frozen states and we point it to the selected combination. So the first state just won't do much. So maybe I just won't put in the frozen state. It's like not existing. And therefore, this is going to create it. Let's try that. So will be null. Just in our pending plan, we just need to specify that this can be null. And therefore, our frozen state won't even have a situation like that. No, but I mean, we always need to have the starting one. But at least it will be starting with a specific combination. Yeah. So um, initial state. Initial state combination ID. And of course, that's a byte. There we go. Okay, this could work. And therefore, we won't have this whole append anymore, the one that causes so many things. We'll just have the this, comma, the new state combination ID. Okay. And yeah, that's it. Bam. But we'll have problems somewhere down here. So advanced state of the plan. So agent ID, plan, frozen state, states length. Oh, we need to track how many, the length of the whole thing. Huh. Hmm. Let's just arrange it a little bit nicer. Byte states count. Okay. And I'll start with 0. Or like 1, because that's the one we're starting with. Okay. Let's do 0. Okay. Start with 0, with initial state of 0. And this way we can keep the whole thing the way it was before. Like the frozen stuff is frozen state. I mean, new frozen state. Now be weeks count, right? Yeah. That's good. And here, frozen states dot states count. That's possibly a null reference. So plan won't have possibility of having it null, okay? Because it will always have it. Okay, cool. New state is all that. And just new state, we need to increase it. What is think? Really, +1 is oh, dear God. Where's the chat? I have this C# code. Byte value is this. Byte states count. Okay. code the C sharp doesn't like that one is not byte. How can I specify a byte literal? I just need to do that. Oh. Okay, I guess I'll just do that. It's kind of dumb. I guess that's why everyone just defaults to int. Okay. Okay, that looks like it could be it. I'll stay combination ID. Yeah, it just holds it there because it's always never accessed. Yeah, we just always save it. Yeah, because right now we don't worry. We'll access it after the whole thing is done. Really? All that's all? That's all it took? Oh wow, that is going way faster compared to the previous one, of course. But what the memory usage will be? Will we actually save memory? If we would save memory here, that would be absolutely awesome. Because we're not copying the whole thing, we're just pointing to a different reference. I mean, garbage collection would have more work, I guess, more stuff to track, but who knows? Maybe it's gonna be worthwhile. Oh, we're already 116 and we barely broke 10 gig. And the more we create, the more we should reuse. Yeah, because when we create an array, we're not creating just the contents of it. We also keep track of the what do you call it? Of the pointer to it, which will be 64 bits. Well, here we're only pointing to the previous state, which already is 64 bits, so we're not really using extra data. Oh, nearly done, nearly done. What is Microsoft Edge running? Seriously? 11 things? Okay, not finished. And task. There we go. Okay, we finished that. That actually was pretty fast, I think. So, wait, where's our spreadsheet here? So, we'll delete all those ugly ones, extract whatever. So, this will be a self-referencing frozen state. So, iterations, the same number, right? Yeah, same number, so things are working correctly. Time will be 130132. Oh, the best time so far. Look at that. Just not creating all those arrays. Yeah, so average time went down significantly. And now let's look at the dynamic program analysis. Our append state still 24741.5. but everything else just disappeared. Array extension append, all that is not there anymore. Still looks like it used some data. We created a lot, but we probably garbage collected even more. I'm gonna run at some point each one of those and try to capture the total usage by program, like top RAM, and this just stays the same, 8191.9. Just see if we can do anything about this. Conflicting plans add. Yeah, that's the thing. We're just adding so many conflicting plans and there's just no way around it. We need to keep adding them to the list. One way is to, instead of just adding them to the list and list keeps growing, we would just have a buffer or something. Maybe. And just add them range by range or something. In theory, the list should already do that. So I'm not sure. It may be already as optimal as possible. But let's do this little quick test. So let's make another helper, another collection that we're gonna try. This will be a buffered list, right? And all we're gonna do here is we're gonna have a backing list, right? So be private list of T. Okay, we just got the new list. And then we're gonna do buffer size, sure, and private T, whatever, that'll be the buffer. Okay. So I'm gonna create it. We just need to create the buffer array. And then we're gonna have add the item. So no, we're not gonna do list add. We're gonna do if buffer dot length is larger or equal, whatever. In this case, will be equal to buffer size. Should we do it after maybe? Huh. We'll always just add it. So it'll be buffer, last element will be item, okay? And then we're gonna do if list count is the buffer size. Then we're gonna do just something like flush, okay? I'm gonna implement flush in a second. So that'll be it. We just added the item. For flush, will be basically list and add range, buffer, and sure. We just do new list or we can clear it. Let's do buffer dot initialize. Let's just ask ChatGPT what's the best way to clear a large list. What's the best way to clear a large array in C#? Back to the default value. Array clear. Oh, array clear. Okay. It's the most efficient way to reset large array because it's highly optimized in the .NET runtime. There we go. Array dot clear. And what do we need to specify here? An array index length. Contents of an array. Just there we go. Whole thing. Which is more performant? Or 0 and buffer size. And yeah. It's negligible. Operation. No value in C#. Okay, I guess it's out of date. Out of date. I just realized list count when we add. Don't want to do that. We also need to keep track of how filled the buffer is. Private and buffer index. We start with 0, okay? And therefore, whenever we add, we just do buffer index increase. And if buffer index is buffer size flush, and flush just adds that, clears, and buffer index is 0. Good. And yeah, that will be public. Why not? Okay. And then we also have public t, and this will be pop. And the whole idea is that this will remove the last element. So if buffer size, no, buffer index is larger than 0. With the buffer index, if it's 0, that means there are no elements, right? Yeah. If it's larger than 0, then we're gonna do return, or no, not really. We're gonna do add range. That's not good here either, because we'll need to send only a part of the buffer. But I think we can do that with a span or something. So buffer index 0, if the buffer index is larger than 0, we're gonna do buffer index minus minus, and then return that part. Oh, that. Okay. But if it's 0, then we're just gonna need to basically return last from the list and shorten the list. So we return list. That doesn't have pop. So we're just gonna do bar item is this thing and remove it. Okay. And this wants to use this thing, and therefore this won't be possible. So I'm just gonna do var item index is this and just reuse it here, okay? And return the item. That's what we're gonna do. When we're removing, we're not reading bunches of stuff to the array. We'll just do that. But here we need to make sure that we do something different. So span of t is list, and we can do probably not list, buffer. Jeez. To buffer index. I think buffer index -1. That's the thing here. Ugh, parentheses, seriously. Span. Instead of to avoid unnecessary data copies. Huh, look at that. A span, and then we're just gonna shorten it. Okay. And therefore we can add a span. This will be implicit conversion from span to read-only span. So let's do read-only span. There you go. Perfect. Can I just do var? And var will say that this is a span. Let's just make it read-only. There we go. It's good enough. And yeah, we could try that. See what happens. Who knows? So this would be the buffered list. We just keep growing it. Okay. And the buffer is for quickly growing, but not quickly making smaller. Okay, cool. So if we have the buffer list here, can we use it for these guys? These are plans, valid plans. Let's use it for pending valid plans. Okay. And all those, okay? We'll use the buffer list for that. Okay. And that just doesn't like this initializer. So new buffer list. And buffer size, oh, because we need to specify pending valid plans. Let's do 25, okay? Whatever, 100, sure. And this here will be another one, and that will be pending conflicting plans. Oof, that'll be more. So let's do maybe 250. Okay. Well, here, for valid plans, let's do 25. And for conflicting plans, 250. Okay. We'll see if we're gonna get any improvement and speed going up, but something tells me list will be already really, really, really optimized. So I don't think it's gonna be an issue. And the only thing is that we are probably missing a few things, like calling count. So let's add count. I'm just not implementing any specific what do you call it? I'm not implementing any specific interfaces on all those. I'm just making like a bare bones simple thing, public uh, int count. Okay. So we list count plus buffer index. And that's it. Okay. It would be kind of nice to have it cached, I guess. Or not really. Do we want to cache it? How many times are we accessing it? Here multiple times, that's not a big deal. No. I mean, we'll be checking for zeros and a bunch of stuff. Yeah, let's cache it. Private and count. Okay. So if we're gonna add something, count plus plus, gonna pop something, count minus minus, and count minus minus. Okay, so it'd be nice to just have defer or something. Defer. Yeah, we don't have that in C# yet. So that's that. And I mean, that's it for now. Count. Alter property. Get private set. Sure. There we go. And that should work. All right. So counts are good. What else? Oh, the access. Oof. Oof. Get next plan. And remove at. Oh, okay. We're just doing pop. Pop. Okay. And then we've got another pop. For now. Ah, done. Run. Okay, what do we have here? No reference exception, of course. Planner line 131. Plan frozen state states count. Wait. Planner line 131. How is that? No reference exception. Frozen state is not set. Frozen state should be always. What the heck just happened? Plan. Plan. Get next plan. Maybe pop isn't working. F plan is no. Throw new exception. It's a non-nullable value. Kind of. Hmm. Um. Why are you showing me that as an error? I would like to just disregard it. There we go. Still not happy? What the hell? Why not happy? It says it can be non-null. I mean, the code doesn't suggest that it could be null at all. So that's interesting. Hmm. Need to see this. Debug. Okay. Good to hear. What is the plan? Oh, the frozen state of the plan is null. Okay. I see. Advanced state of the plan. This 0. Okay. Don't like having it here, but oh well. But wait, why would have no frozen state? Whenever we create a new plan, we give it the frozen state. And that's during the initial thing. Okay. Yeah, it's given here. So this shouldn't be a problem. What the heck? Yeah, we have a new plan. All that. And add it. All this stuff. So the moment we go in here for the first time, we should already have it in place. Okay, I want to see. Right now, plan is nothing. This pending valid plans. We have 3 of them. Count as 2 for some reason. Okay. Buffer index is 2. Even though it should be 3. This one here. There's nothing here. And what the bleep? We're not saving something here. Conflicting plans. And not here in the buffer. We have some conflicting plans. Okay. One conflicting and one invalid. What happened to the other one? Valid plans. Buffer. Also, state is null. 1. Where's the 0? Did I override it or something? What the hell just happened? Why are those simple data types so difficult to just get right? Add. What? I guess that's just using AI. It inserts a little error here, a little error there. Because why not? Sure. There we go. Now we should have it working. Well, it's working. I don't know if it's going faster or not. I don't think it's gonna go faster. We're just running more code. I think. I mean, conflicting plans is already like the non in progress ones are, wow, that's a lot. 150 million. So I guess it's good we're running them in chunks. I think. One gigs. How far up are we going to get? 24, 25. 28. We're gonna get to 30. 30. Okay. Oh, exception. Oh, that's interesting. What the hell? Randomly here. Um, line 44. Okay, we did pop. And we run out of items in the list. Yeah, because buffer index is 0. So I guess that's the first time we run out of stuff in the list towards the end. And number 44. List count -1. Oh, because we're not checking if there's stuff on the list still? Planner line 210. Planner CS line 210. If count is larger than 0, then pop. So it was larger than 0 somehow. Well, here so let's say it was 1, right? So we should do 0 and list item index 0. Okay. Handling the count in both. So let's say I want to pause here. Is it really gonna be towards the end? Not this. Let's continue. Yeah, we're instantly going here. Combination is 0. So item index, whoa, okay. Count, not many count, but buffer is 0. So that doesn't have an issue here. Bam, 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 bam. List count is that much. What is the count overall of this? Is it aligned? Count is 3981. Buffer index is 0. Okay, so we have discrepancy here. Something ain't right. If our list count doesn't match the other stuff, that's bad. So how does that happen? So when we pop and we remove it from the buffer, we remove both buffer index and the count. If we pop it from the list, we remove it from the list. Okay, we just get the index of the last element, take it from there, remove it from there, and decrease the count and return the item. So we're good with removing. But what with adding? Unless we need to recalculate the... No, whenever we flash it to the list, the count shouldn't change either. So when we do add, our index will increase. We might flush stuff. And we increase the count. And we shouldn't have any garbage collection doing stuff here either, right? Yeah. So what is going on? So we start with the count at 0, right? That's obvious. Whenever we add, we always increase the count by 1. So that's fine, because we can add only one element. When we flush, we transfer stuff from the buffer to the list, okay? And therefore our count should not change, okay? Because we still have the same number of elements. And when we pop it off the list, if we still have data on the buffer, we simply decrease the count. So we're good here. But otherwise, if the buffer was empty, we just go to the actual list, take the last element, remove it, and decrease the count. So we're good here too. So how on earth does the discrepancy happen here? I don't understand. Let's run it again and see what happens. Because this is truly strange. Did I remove the thing? I need the thing on pop. Okay. We popped something. We buffer 9. And so the count is supposed to be 2748. Okay. 2748. On our buffer index, we have 9 elements. And in the list, we have 2712 elements. So if we're going to get count of the list, 2712, add 9 that we have on the buffer, how the hell do we have count of basically 30 more items? What? So our count is larger than the actual number of elements. And the only time if I double click count, we have here, we do it once when we add element. And here we decrease it. So what the hedge? Any ideas? Truly confused. And yeah, this reports a different count. What the heck? Do I need to literally recalculate it every time? Or am I maybe... No, it shouldn't be a problem. Maybe I'm mishandling the other counter and I'm just wrong. That might be it. So if we go back to our list here. So if we have our pop, the buffer index gets decreased once here, okay? So we're good with that. And then we return, so we forget about it. When we have this situation, oh, we don't decrease our buffer index? Oh yeah, we don't decrease it because it's already 0, and here we're not doing anything with the buffer, we're just taking things from the list, okay? So that's good. What about adding? Oh, we increase our buffer index every time. And when we flush it, we just put it to 0. Is it the case that maybe every time we flush it, we are actually missing something? Because buffer index is at 0 because we have 0 elements. If we have 1 element, we have 1. And therefore, this would get only 1 element added. Unless there's something wrong with here. Let's try that and see if that works. Just gonna run it a bit. And what now? We just have pop. Buffer index is 2. And you know what? Let's run a little bit longer. And bam. 183. Okay. So let's see. Our count is 3,700. The list has 3,517. We add 3 will be 20, 200. Okay, this is good so far. Let's continue a little bit more. And stop. And 93, 10. So we should have 3183. Okay, we might have fixed it. Yep. Let's stop it and let's it run the whole thing. Because that might be it. And if that's gonna be it, I'll be very, very, very happy. And we'll finally see if adding this buffer list decrease the memory usage, or maybe, I don't know, increase something. I expect that they made the whole thing a little bit slower. Okay. Viewer, if you're watching there still, this takes usually a minute and a half, something like that. And we're gonna see if we have any good results. So let me bring up our spreadsheet. Where the hell I put it? There we go. Our lovely spreadsheet. So this one will be with buffered list. Okay, we'll have the same number of iterations, but the question is how fast it's gonna go. And what the memory use, I mean, memory usage should be the same, roughly, right? What the hell is chugging randomly from time to time? I wonder, like, anti-malware might be doing it, not good things. Probably. Or just Windows. It'll be interesting to run it on Linux and see how that would differ. If it will be faster, slower, I don't know. Interesting idea. Come on, nearly there. It's 44 million. Another chug. Huh. Okay, 20 more million. And 10. Oh, okay. Bam. Okay, so time wasn't that much slower, right? 131.871.48. So that's pretty much the same. Okay. I'd say that it's within a range of error. And then let's see what kind of errors we have that it complains about. Only 2. Look at that. So basically our append state stays at 24741.9 somehow. And then we have our flush showing up now. But our flush previously was this whole thing frozen state. But now the similar thing just went to 7984.4. Thing is, we don't have the metric of the total RAM usage, but that will be roughly the same. The only place where I will see any difference is possibly in performance. And I guess now that we saw that we make hundreds of millions of the specific thing of the is it in the planner? Yeah, in the planner. Conflicting plans, like the finalized ones. We made a buffer of 250, but really there are just hundreds of millions of them that we're creating. So let's make it like, I don't know, 250,000. Okay, for valid plans, we have none right now, and usually it's a small number, so that's fine. For pending conflicting plans, let's do something like 1,000. And that should be fine. And valid plans, we don't care. So I'm gonna rerun it again, and if we're not gonna get a significant time difference, I guess the whole thing is pointless. At least we'll know. For now, we can just Teti says, wow, to set up this fire ends. Not sure what that means. Okay, we're 1/3 through. But yeah, we decreased that from this state. Usually it was already taking up like, what, 20 gigabytes of RAM. Now by this time it's only 12, so hey, that's an improvement, I'd say. Okay, I think we're roughly halfway through. I don't know if it's going faster or not. I truly don't know. Let's grab the spreadsheet and we're just gonna do what was it? Conflicting buffer 25 150k. And we'll see if there's any difference. Okay, a little bit more. Hey, is it that we're not even gonna break 29 I mean 30 gigabytes of usage? No, we are, I think. Yep. And 30. Oh, but we didn't go 31, so that's not bad. And the time is roughly the same again, although it's going a little bit up. 133492. Okay. 0.85, whatever. So that's not great. And when it comes to usage, Penn States, they pretty much the same. 24741.8. And the flash, I guess, stayed the same. So one of them, which one is it usually? Conflicting plans add. Did it go up or down or the same? Kind of went down. Okay. So that's not bad. And this one will be probably for something else. I mean, this one. What is this one? Same thing. So why is it as two separate things? No idea. But I guess it's kind of pointless. It's made the whole thing slower while not really improving anything. So here the max was 31 gigabytes. Okay, we're just gonna go with full gigabytes. So I'm gonna do it in a way that where is it? Here. So let's just make a new branch. It will be the 50,000k. That will be our branch name. I want to go back to where we just fixed the loop. Oh, hello, Drunken. Didn't know you were watching. I'm gonna create a branch here. That will be the any. And we're here now, okay? Wait, what happened? I have, this is work in progress. Let's just stash it. Yeah, sure, whatever. So now I'm at any branch, the thing that we had before we did this whole array thing. So would be, oh, I don't have self-reference there. Committed. No, I have. Where did I add the self-reference? Also state. Oh, it is here. Okay. So yeah. Let's go back there. I'm messing up a little bit. So we go back to main, right? And we're gonna do apply stash, right? What we're gonna do is commit the frozen state because that's the one that matters and that actually improves things. So we're gonna do this, and in the planner, do we have anything that was regarding the frozen state? Yeah, this line, and that was it. So yeah, so let's just do self-referencing frozen state. Okay, commit that one because that was actual improvement. And let's remove this little thingy, whatever this thing is. Delete. So let's do branch to 50k. And we're gonna just push those things and it'll be 50k test. Like buffered list. Sure. I don't know why I pushed it, but okay. So okay, let's go to our main, which is self-referencing without, which is this one. I just want to mention how many gigs it used when we ran it. So I'm going back here. We have everything back to normal, right? Yes, just normal list. So I can just run it and observe the RAM usage manually with my eye through the very slow Windows, whatever you call it, task manager. At least I know that it ends at 360 million total iterations. I'm just gonna sit here for a moment and wait. And I guess some people are waking up or something, or it's a good time to stream because it's 5:15 a.m. here, and I'm not going to sleep today. Tonight, at least for me tonight or this morning. So we'll see. My wife gets up in 45 minutes, so I'll need to be done in that time. Okay, come on. Sometimes we had better RAM usage before the whole thing. Okay, we got the 20 gigs. Okay, we've got 300. 10. 20. 30. Okay. Big hiccup for no reason. Okay, we've got the 30. 30 and a half. 30 and a half. Look at that. Tiny bit better, I guess, right? So that's good. 30.5 gigabytes. I think here was 30.9 gigabytes. Okay. So this whole buffer list kind of sucked, as expected. So now I can just quickly go back to the thing prior to this. Where is the thing? I just want to have proper measurements. So before we did the self-referencing frozen state, we did just the any turned into a loop. So this is where back where the frozen state actually held a list of combinations. And yeah, let's see how that goes. That's the one, right? Self-ref frozen state. Just gonna run it. Sorry that the end of the stream is a little bit boring, but I'm up for a chat. So ask questions, share your opinions, share your what's on your mind. Yeah, we're at 130 and we're already at 15 gigabytes. Wow. Okay. That self-referencing actually did a lot when it comes to RAM usage, huh? Oh, it's slowing down so much for some reason. What's going on? And the lead counter was just using the 30% of CPU. What the heck? Okay. 32 gigs already? Wow. 34. 36 gigabytes of RAM used. Jeez. Chugging for some reason. Okay, 41 and a half. 42. Okay. 42.2 gigabytes. Holy moly, we saved 12 gigabytes just by implementing this self-referencing state. Wow. Yeah, if it's a Microsoft product, it's probably phoning home, sending your data to them. Possibly, but I don't think they're sending data about that. Alrighty, so wait, that was this actually. Yeah, this was that, and yeah, good. So I have just two more tests to run. One was when we changed all the integers into bytes. Here. So we're gonna create a branch here. Byte. Okay. And that means that our frozen state and everything uses. Did I check into the branch? Oh yeah. It's just any loop was not there yet, which led to massive amount of enumerables to be created. Okay. More tests. Yeah, I think that changing all the integers into bytes, which is, int 8, was like another big change. But I really wonder what's the difference between, because what we're checking now is basically that, because we're going with optimizations backwards, as in we're removing them one by one right now. So we're going from the situation where we had a for loop to the situation where the for loop is replaced with the any, which is like an iterator thingy, but each time you start that iteration, it creates a separate object that is that whatever enumerator, whatever that allows for enumeration that you're calling give me next, give me next, give me next. And because we're running roughly 500,000 loops a a second, we're creating that iterator object 500,000 times a second, because and that kind of generates a bunch of little tiny bits of data that garbage collection needs to go on and delete. And each object has its own pointer, so that's basically int64. And yeah, that kind of causes problems, I guess. That's where probably spans would be useful for using in some areas where we're using like list right now, where we have a link to a list and to an array. An array is passed by reference. Therefore, we have an array with the data and we have the what do you call it? The reference to it. If we would have one large array already sitting somewhere out there, we could simply make spans, which is basically the object that span already has a link to an array, so it kind of doesn't make any sense. Wouldn't make any difference, I think. Yep. Thinking wrong way. We could make our own objects that don't point to the array, that just hold the start and end point, and just use that instead. That could be something. Oh, we already finished, and I didn't look. Oh no. Crap. Seriously? Can I see it in here? What just happened? Yeah. Let's rewatch it. Gosh, really? That's the quality of the stream? That can be. I hope that's not the quality of the live stream. 360p. Because I can't even see it. What the heck? Or is it just a preview for me when I'm running here? Does C# allow for inline assembly? I think it does to some extent, but I am not sure. That's a good question. Where's ChatGPT? Because that's a question. I never thought about doing that, because C# is interpreted language. It runs in a in the VM or whatever. Does C# allow to inline assembly? No, does not. Yeah, I guess it's not. You could time for invocation. You can just assign DLLs and call DLLs. I guess that's it. Huh. Yeah, it goes on. So let me just check the live stream. I guess I need to share it and copy it. Let's see, because I'm not rerunning that damn thing. Although I will probably be halfway through. Oops. I was hearing myself. So I was for loop to the situation creator thingy. Be quiet. Let's fast forward it. That's so weird. Okay, the stream looks good. You can read everything. Good. I actually never bothered watching it much. So this finished here. 31, 38. Oh. 38 gigs? What the hell? Am I watching the correct thing? Yeah. Hmm. Okay. Great. Um. So somehow, where's the? I'm keeping changing things. I still can't get used to this browser. 38 gigs. What the hell? That's actually unexpected that from not assigning. What the hell am I doing? Um, where do I switch? Where am I now? I'm at the point where we switch from integers to bytes. But I reversed the loop. So link any was using less RAM for some reason. Go figure. I don't know, but removing it basically made it so that it went faster at least. I don't know how this happens because what? We must have run a fluke or something. I don't understand. It's very strange. But what matters now is the initial baseline. So we have switch back to basically here. Green branch here, baseline. We're at baseline, so everything uses ints. We'll run that, and that's our last test here. The before optimizations world. And yeah, we see that, and we can have that ready. And maybe we'll be just using only 20 gigs, so it's gonna say, you know what, their optimizations were pointless. That'll be the weirdest thing. But yeah, okay. Yeah, C# we can't you can't use assembly because it basically C# is compiled to something called intermediate language that then is executed by the VM whatever by .NET runtime. And the whole idea about this interpreted language is that you can have various different languages that can compile to that interpreted languages. So we have, for example, F#. F# is a specifically functional language. And now there's a bunch of other languages like that. I think there's also something called Iron Python, which is Python that compiles to .NET stuff rather than whatever you call it, rather than whatever Python has their own thing. And the nice thing about it is that if your language compiles down to this interpreted language, suddenly your language can use all the libraries and other, maybe not libraries, but all the other basically modules, or yeah, let's call it modules or packages that were written in other languages that were compiled down to this intermediate language. So you would be able to use, C# packages and share types with those, and with F# and with other things. So you have nice interoperability, which is nice. Yeah, it's actually a pretty decent ecosystem, to be honest. Many people think it's Microsoft and it's like, oh, it's bad and whatnot, but it's actually pretty decent and often pretty optimized. C# isn't slow. I'm getting much better results than with the NIM code that I wrote. But I mean, the fact is that the nim code I wrote was not the best, and I completely changed approach here, so I guess it could be faster, but hey, maybe I'm gonna rewrite it to nim again. But right now the tooling just makes me not want to do anything with nim. But hey, today actually will be a live stream with nim, and I don't have a topic yet. Okay, we're approaching. We're already at 46 gigabytes of RAM. 47, 48, 49, 50, 51.1, 44.6.9. Okay. Wait, what number? 0.9? Was it 54.9? What the hell was I saying? Oh no, I need to check my stream again. I think it was 54.9. Ay. Copy the live stream and quickly check the thing. So, what was it here? Okay, we had 34, 35, 37. We've got 51.9. Okay. I don't know where I got 54 from. 51.9 gigabytes. Okay, so to go from 51, 30 gigabytes of memory usage, okay, not bad, especially that we went from one speed to the other. Okay. Yes, sure, can be pretty optimized at times. And I mean, we're not actually doing anything crazy here. Because for the whole thing, you know, we have an object planner. And the good thing is that I basically pre-calculated all the possible combinations and then pre-calculated all the possible states of using those combinations for those agents. Therefore, we're not even storing it anywhere. It's just one spot. And each plan is just a list of numbers like, hey, combination number 2 of the agent 1, combination number 3 of the agent 2, combination number 0 of agent 3, etc., etc. So, you know, not a lot of data stored. Plans also only valid and conflicting. I mean, here the whole data that's being stored basically is the conflicting plans, which are plans that have a conflict in them, which is basically one agent being like this, where there's no arrangement of booking days where 2 days aren't consecutive. And we have, I think, like 150 million of them stored, 150 million possible, what do you call them? Possible conflicting plans. And that's the problem. We're just storing that many. The thing that could happen as another optimization is that maybe every time I have this little break in iteration that I'm printing stuff here. Yeah, because we have our while loop where we basically, other than measuring time, we're just getting the, you know, process next plan, just simple iteration. And then basically at this point, 500,000 iterations, we're just printing stuff. But what we could do, we could add here that, hey, if the number of conflicting plans is greater than this, remove the worst ones. And that would mean that we need to pause and score them and maybe keep 100 best ones. Or I don't know, whatever the number would be. Just a few best ones. And this way we discard all of the other ones. That would allow garbage collection to collect probably, several million, whatever. This more objects than the plants. And that could be something. Yeah. So basically what would need to happen is assigning scores. And I could actually make a real quick score thingy. Yeah. Huh. So, let's make a new helper. Not really. Models planner. What the hell? Let's just add new class. Plan score. How would implementing multiple threads increase the speed? Drastically. And the thing is that this actually would easily support multiple cores. I was trying for approaches that wouldn't support that, but here you could 100% do that. Hey, yeah, maybe instead of scores, let's implement multi-threading, right? Although I don't know if I can do that in C#. I haven't done that in a long time. But the first thing would be that in our planner, we need to make a few things that we're writing to thread safe. We're not writing to here, we're not writing to here, nor here. We're writing to those lists, okay? So we would need to make them concurrent. So pending valid plan is concurrent. Oh, queue would be interesting because we're kind of using them as queues. But no, stack. That's what we're using them as. Concurrent stack. Okay. And this will be the same thing. While for valid and conflicting plans, it will be concurrent bag, I think they call it. Go figure. So we just changed the types. We just need to fix a few things of how we're accessing it, right? So for pending valid plans, because it's a stack, we don't have add, we have probably push, okay? The same thing with push here. And keep in mind, that's already, the whole collection guarantees that it's thread safe to call those. Pending valid plans, push. Pending valid plans, push. And another push. Well, here we have pending valid plans. Instead of doing this whole thing, we should be able to just do .pop, try pop. Ha. Attempts to pop and return the object at the top. Okay. When method returns successful, return contains the object removed. No object. Wait. Try pop basically has an out object. Okay, so that's what we can do. So here when we get next plan, we try first to get the ones from valid ones and then the pending conflicting ones. Because we have logic where when we find at least one valid plan, we ignore everything that has conflicts to just skip it. So we can do basically if this, and this will be out and create a new variable plan, or like valid plan. We're just gonna return valid plan, okay? Well, here we're gonna do the same thing, but instead of this will be sort of valid, will have conflicting and conflicting plan, whatever. Let's just do return conf plan. So look at that. Code actually became simpler. Okay, so we're done with errors and changes. We have it concurrent. The only thing will be to also have this total plans count and invalid plans count. We could have locks on them, but at the same time it kind of sucks. So let's ignore that for now. Now, how the hell could I do threads? Because the thing is that I can just split things into multiple threads, let them run, because we have kind of tree, so we can get few branches of the tree and just let each branch run and do stuff here. That's one thing. The other one will be just for them to keep going and doing things, but yeah, but that means that each one thread would need to have their own things. I'd rather have them just keep chugging at the stuff that exists, and just when all the lists are empty for a while, only then stop, right? That could work probably. And this way they can just cooperate on whatever's next on the list. So let's think. I mean, there will be some locking and unlocking, but the locking itself isn't difficult. The rest of the computations are just resource heavy. So let's just ask ChatGPT how I can, for some kind of example of creating multiple threads and ending them. Show me an example of a simple. Show me a simple example of creating multiple threads and executing some code on them. Although I don't think I'm gonna be able to do it in 15 minutes because I'll need to go start making breakfast for my wife. Alrighty, create multiple threads. Okay, so we're gonna make 5 of them. Thread number. Oh, create a new thread. Do work. In this case, it's the work is literally this thing. And that's it. Okay. That's literally it. So, yeah, let's just copy it. So in our, yeah, that's probably what we can do is as we start iterations, we could actually make it more in a way of each thread having their own iterations and just, yeah. So I'm just gonna put that here. So let's say that we're gonna do 10 threads. Okay. And we're gonna grab all that and what? We don't want stopwatches. We don't care about that part. Not the number of iterations. All we care about if it's finished and a bunch of other stuff. So let's do that. So let's basically make a little method down here. We'll call it, I don't know if I need to do private static. Wait, do I have like a class here? No. Let's do run planner thread. Okay. And we're not gonna give it anything other than paste in the text. Okay. And it returns void. Okay. Or yeah, that's it. So we're gonna do it very simply. Let me think. So has finished is basically used in a way that, hey, Did it finish? And let me just get rid of stopwatches and all the stupid little uh, things. Let's actually do the iteration because we need iteration counter. So let's do var iteration is 0 here. So each one will be tracking of its iteration, and we'll just give it thread number. So let's think int thread number. Okay. So they have a thread number, and when we print, we can do number, and this will be, let's just change it into this thread number. Okay. And iteration, and that will be it. Gosh, I have crazy music going. What the hell? Okay. And we just print the stats. And we don't do measurements. So that's that, right? Hides outer, yeah, whatever. So I am able to actually comment it out, okay? And we don't need those either. Nor all those measurement things right now either. So, yeah. Finished. Period. Okay. So what we're gonna do is not call do work, we're gonna call run planner. And this will be the thread number. And start them. And they should all finish at some point, right? And can I wait on them? Var list of threads, okay, and we're basically gonna do threads add, okay. Okay, so threads add, and I should be able to do threads dot when, where, how can I wait for them? I don't know. How can I wait for a list of threads to finish? You can like call join or something. Thread the join method. I guess for each, yeah, for each one of them, I need to call join. So that will wait for each of them. Not the most optimal, but we can do for each thread and threads join. Okay, so it'll be wait for all threads to finish. So the only thing that I'm thinking now is that if we're gonna start running them at the same time, there won't be enough stuff on the list here to start going yet. So what we're gonna do is that if we have has finished, let's do var number of finishes 0. And what we're gonna do is if number of finishes is 0, we're gonna basically do wait for 1000 milliseconds. Yeah, right. And then we're gonna do run again. So what we're gonna do is, I think I can, how the hell did that thing work? So we're gonna just do has finished false. We go to start loop. Okay. Start loop, something like that. Okay. We're gonna use go-to because why not? And that should be, oh, number of times finished. So if it's 1, then we're gonna do that. If not, it's gonna start again. This way we're not gonna have a situation where we're on all threads. So let's quickly try to run it, okay, and see how it fails. It's doing stuff. I don't know if it's going faster or not. But when that finishes, I will need to stop because it's getting late. But hey, that's running multi-threaded. If we're gonna get the same number of results or something, that would be awesome. So far we're at 60 million only. When I look at the processor, we're not doing that much more. Performance-wise on CPU, I mean, a bunch of CPUs are doing things. So it's not that impressive. Let's stop it and let's make it, I don't know. How many threads do I have? 1, 2, 3, 4, 5, 6 times 4, that's 24. So let's make it 24 threads. I think there's just a bunch of locking there. They would need to copy a bunch of their own stuff and work on their own stuff and then add it to the main thread from time to time. Because right now they're all waiting probably on a list for each other. Like, 24 things locking each other. Yeah, because we're already at 50 million, but I don't know if that's fast or not. Confusing. That shows like, in progress. Oh, I see. Sometimes in progress goes down to 0, but no, conflicting, there's plenty of them. So they have plenty of stuff to do. Okay. Yeah, but I don't think it's going faster right now somehow. Yeah, this is not going faster. All right, I'm gonna end the stream now. I need to go and make breakfast. So thank you for hanging out. Thank you for joining me on this optimization journey. And hey, take care till the next time. See ya.